Awe owens horse dalaros. Sorry, most of you think that I'm not South African. I find it quite offensive. You know how many comments I get in the YouTube channel and people are like, "Sir, you're helping us so much. Love all the way from South Africa." I'm like a home slice. I live here. I'm born here. Guys, I'm South African. So if you want to download this paper, just check the description below. Let's get started. Okay, so here's where we have to solve for x. Obviously very easy. Now remember, when they already have brackets like this, you need to go multiply this x inside. If you did, you would end up with this. And then what would you do here? Well, this is pretty awkward, right? Because you would probably take out an x as a common factor, and then you would end up with the same thing. So you don't need to go multiply it out if it already has brackets. Something that some learners do that's incorrect is they do this, and then they take the 3x to the other side, and then they're like, oh, I can just cancel the x's, and then they say x is 3. It's not correct. Okay, what you want to rather do is, if you ever have a situation like this, for example, you want to take the 3x over to the left-hand side so that it looks like this, and then you would factorize so that it looks like that. Okay, so when it does look like this, what do we do then? Well, all that you do is you just say x equals to 0 or x minus 3 equals to 0. It's like having x plus 2 bracket x minus 1 equals to 0. What would you do here? You would say x plus 2 equals to 0 or x minus 1 is equal to 0. So now we're doing the same thing. We're saying that this part is equal to 0 or this part is equal to 0. You could almost imagine that there's a bracket there. And so there we've solved for that one. And then for this part here, you're just going to take x to the other side and you're going to say x is 3. Now some of you are like, yeah, Kev, but check, bro. Now I can see we did get the same answer. Yes, I agree, you did get that one. But my bro, where's this one? Exactly. So you need to, just remember that. Okay. So now this one over here, when they say correct to 2 decimal places, that is a clear indication that you are going to have to use the quadratic formula. So let's quickly go write that out. Always going to be given to you on your formula sheet. So it's this one. Okay, Kevin, I saw that one class, my bro, but I don't know what to do. Okay, if you're saying that right now, then that's a bit of a problem, because by now you would expect, well, I would expect that you've used this formula a lot. So I wouldn't want this formula to be something that you're not quite sure what happens. But yeah, that was just a joke. I'm sure most of you know what this formula is. If not, a bit awkward right now, isn't it? Okay, so what you're going to do, guys, we can never factorize, well, we can never use the formula like this. We always want to make a 0. So how do I do that? I take the 4x over to the other side. There we go. Now remember, this part over here is A, this part over here is B, and this part over here is C. Okay, now some learners do struggle with the typing it in on the calculator. So remember, what it says is that there is already a negative there. So just put that negative there. Now, what is the value of B? B is -4. So I want you to put that in a bracket, okay? Then you're going to either choose a plus or a minus. You can't choose both. So I'm just going to choose plus for now. Now, I see there's a B square. So I must put my B in a bracket, especially because it's negative. Then I'm going to say -4. Now, A is just a 2 and C is +1. Okay, and then I'm going to put that all over 2, and then A is 2. Okay, and that's all that you need to show. And now you can go type it in on your calculator. And to 2 decimal places, we should get x equals to 1.71, 0.29. So we have a inequality. So what we do with inequalities is you want to pretend that this is like an equal sign, and you want to go solve that, but you want to do it like on the side of your page here, and you can even say here critical. You want to get your critical values on the number line. Okay, and so you're going to make it equal to 0 like that. Then you're going to factorize this or use the formula, whatever you prefer. So it's going to be what's this one going to be? X take away 3 and x plus 1. X squared, yeah, that works. And so we're going to say that x minus 3 is equal to 0 or x plus 1 is equal to 0. Therefore, x must be 3 or x is -1. What some learners do at this point, which is incorrect, this next part is incorrect, what they'll do is they'll just say, oh, okay, so we're just going to change this back to that now. So we're just going to say x is bigger than 3 or x is bigger than -1. Not correct at all. What you rather want to do at this stage is you want to now go draw like a number line or something like that, and you want to go put these two numbers on that number line. So -1 would be on the left and 3 would be on the right. You got to look at this graph. You got to think of it as a graph. What type of graph is that? It's a parabola. Now, parabolas can either be happy. You see what I mean? If that's a happy, you can see the smiley face over there. Someone's happy. Or it's sad. The way we tell is we look at the thing in front of the x square. If it's a positive, which is in this case it's a 1, then it's happy. Positive, happy. Negative, sad. So when it's positive, it's happy. If you're feeling positive, you're feeling happy. Okay, Kevin, we get it, dude. We're not like 6 years old. Can we move on? Okay, so what we now do is they said, where is this parabola? Where is it bigger than 0? What that means is above. So this is the x-axis. And they want to know, where is that graph above? So we can see it's above. So what are the x values there? Well, all of the x values here are all the x values to the left of -1. So we'll say it's all the x values that are smaller than -1. I'll also show you interval notation now. And then the other one would be all of these x values over here. And we can see that they are all the x values that are to the right of 3. So they are bigger than the number 3. We say like that. If you wanted to do, oh, by the way, some learners are like, okay, sir, can't we just do something like this then? Can't we just say x and then it's facing the -1 and it's this thing is facing the x? Can't we do something like that? Absolutely not. The only time we do something like that is when your answer is in the middle part over here. Then that technique makes sense. But Kev, why doesn't it make sense now? Let me explain. So it would have looked like this. So what this tells me, right? This tells me that x is a number that is bigger than 3, but it is also smaller than -1. That is impossible. You cannot have a number that is bigger than 3, but it's also smaller than -1. There is no number that exists that satisfies that. So when you have it like this, you are saying and. So you are saying that x is smaller than -1 and it's also bigger than 3. That is impossible. But you can have this be true. X is a number that is smaller than -1. Okay, so that's all of this. Or, you see, we're not saying and, we're saying or, which means it doesn't have to be both. It can be one or the other. Or x can be bigger than 3. So that there is numbers that exist that can satisfy that. As soon as you try to group them together, then you are saying and is very, it's a lot more difficult for something to be and. Okay. And then if you want to do interval notation for this part over here, you would say -infinity up to -1. And we're just going to use round brackets because they haven't included. And then you would say or if you're cool, you can also say that. Oh, and we typically, for interval notation, we also put x as an element. And then we say or, and then this part over here would go from 3 up to infinity. You see, so this area here goes all the way to -infinity. So I always say, I say -infinity up to -1. That's what I've got over there. And then this one over here goes from 3 to infinity. And that's why I've got it there. So whenever you put it into these brackets, it's always the left and then the right. So this is the left and this is on the right. And then this is on the left and this is on the right. Let me explain. So in this, just this area over here, which is on the left? -infinity, so I put that first. Which is on the right? -1, so I put that over there. And then when I'm looking at this part over here, the 3 is on the left and the infinity is on the right. So here we have a trinomial looking type of thing. Oh, and this is just a solve for x type of question. I think I forgot to put that there. It looks like a trinomial, right? And what I notice is that here I've got a 2x and here I've got an x. So that is a perfect trinomial. Did you know that a trinomial is anything that has this one being double this one? So for example, if I have x to the 8 minus 3x to the 4 minus 4, for example, that is a trinomial because this one is a 4 and this one is a 8. So a trinomial is whenever the one is double the other. So when we notice something like that, then we've definitely got a trinomial. But the problem is we have this little +2. So what we're going to do is we're just going to try split this up so long because we should know that that can actually be written as 2 to the x and 2 to the 2. I'm going to go write it like that so long. Now remember that 2 to the 2 is just 4. I can actually go rewrite this thing now as almost like that, okay? Now, see how, or let's just look at this part here. Did you know that that part there can be written as 2 to the x to the 2? Because these two are supposed to be multiplied, so it would give you the 2x. The reason I've done that is just to help me explain. We can now, you see, we've got that part over there that is the same. So we can now, for example, say, let that part equal k, for example. Because then what you end up with is k squared minus 4k minus 32. And that over there, my dear friends, is a beautiful trinomial that we are very used to seeing. So now we're just going to go factorize this as, let's get rid of this over here. And so that's going to become, let me think about that. So we look at the factors of 32. So 32 could be written as 1 times 32, 2 times 16, 4 times 8. There we go. We know that 4 and 8 can help us to make minus 4. We could say minus 8 plus 4. Why did I say that? Because minus 8, that would give me minus 4. Okay, so now we can say, therefore, k minus 8, k minus 8 must be 0, or k plus 4 must be 0. So therefore, k must be 8, or k is negative 4. Now we're not done because the question didn't say solve for k, it said solve for x. But we know that we have this now. So we can now say that, okay, so 2x is equal to 8, or 2x is equal to negative 4. So to solve this one, if you are in grade 12, you're welcome to use logs, but I'm just going to use more of like a grade 11 approach so that this, so that it helps grade 11s and grade 12s. But I know that 8 is the same as 2 to the 3 if I do that whole shift fact blah blah blah, and then I end up with x equals to 3. This one over here, you're going to get a no solution. There is no number that you can put over there that'll end up giving you negative 4. Okay, I'll show you another way that doesn't work. If you're grade 12 and you use logs, you would get an error. And if you are just want to think about this as a exponential graph, that is a normal exponential, right? Just the standard vanilla exponential. There is nowhere or no place where this exponential has a y value of minus 4. Minus 4 is down here, and you see that the graph never gets to that point. So there is no solution for that one. So the only answer is going to be x equals to 3. We have a square root equation. As soon as you see a square root equation, I want you to immediately remember now already that to do a way that we solve square root equations is we want to have the square root by itself. So we're going to take this minus x to the other side. So it'll just become x plus 2. Then what we do is we square both sides. So we take this to the power of 2. Now what a lot of learners do wrong is they just go put a 2 here and a 2 here. You don't want to do that. You want to take whatever you have, put it in one big bracket, and then say to the power of, because remember, not the same. What you're thinking of is if you have something like this. Then you can put the 2 there and there. But as soon as you have a plus or a minus in the middle, then it becomes more than one term, and then you can no longer use that property. Okay, so remember that this actually becomes a double bracket and it ends up becoming a trinomial actually. Remember that this 2 dissolves square root, and so we are left with whatever is inside the square root. Now this part here, you're going to go make double brackets. There we go, good stuff. And then you're going to multiply out x squared plus, it's going to become 2x plus 2x, which is 4x plus 4. Now we just have an easy question where it's just a trinomial. So I'm going to take everything to the right. You can also take everything to the left. It doesn't matter. We're going to end up with 6x over here and then plus 0 because these two are going to cancel each other out. Now what some learners do that's incorrect is they now think that we're just going to take this 6x to the other side and then we're going to divide by x. Not allowed. Instead, you want everything on the one side and then you are going to factorize. And so we're going to take an x out. You'd be left with x plus 6. And then you could say, therefore, x must be 0 or x plus 6 must be 0. And so therefore, x is 0 or x is minus 6. Up until that point, you would probably get 3 out of 4. To get full marks, we have to do how do we do that check? Let's do that now. Okay, so let's go do a check. So you're going to just start with the first one, x is 0. And all that I want you to do, yes, there's other weird ways that teachers show and blah, 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 but the simplest way, in my opinion, is you're just going to go plug in 0 on the left-hand side. You're going to go plug in 0 on the right-hand side. So on the left-hand side, if we go plug that in, we're going to have minus 2 times 0 plus 4 minus 0, and that gives us, if you go work that out, that's going to give you 2. And then if you look at the right hand side, it is just a 2. So those ones work perfectly. So x equals to 0 is a valid solution. Now let's go try with x equals to, what was our other answer, guys? Minus 6. Let's actually do that one up at the top of here. So if x equals minus 6. Okay, so same thing. You go plug in on the left hand side, and so that's going to become minus 2 times minus 6 plus 4 minus, and then x is minus 6. Okay, and if we had to go work this all out, we're going to end up with on the inside here, we're going to end up with 4 plus 6, which is 10, okay? But on the right-hand side, we still just have a 2. So is 10 equal to 2? Well, no. So this minus 6 isn't making any sense, and so that one will be a no solution. So we can just put a line through that one over there. Now we are going to solve for x and y simultaneously. So the way I always tell learners to do it is you've got these two equations, right? Number 1 and number 2. Go find the easiest one. That'll give you a y or a x alone. So there I can see there's a y alone immediately. So if that's equation number 1 and that's equation number 2, I'm now going to take equation number 1 and I'm going to rearrange it by taking the 2x to the other side. So you see I kept this on this side and then I took this over to the other side. And I'm going to call that equation 3 now. Then what we do is we're going to go substitute this new equation 3 into the one that we haven't used yet, which is number 2. So what it means is that now wherever I see a y, I'm going to replace it that, because it says here y is equal this. And so that means that this and this is the same. So wherever I see a y, I can take it out and I can replace it with that. So I'm going to end up with, so now I've taken this equation here, and wherever I see a y, I've just made a bracket. And then here I saw a y, so I made a bracket. And I'm going to go put the 3 minus 2x into that. 3 minus 2x. Wonderful. Now we're going to just go simplify, neaten this up, and solve for x. Remember that when you have a situation like this, please remember to do double brackets, or you can just multiply it out in your head if you're comfortable with that. Some learners are. And then we're going to multiply this out. So 3 times 2 is 9. Don't say 6. I know it sometimes catches you in exam. Minus 6 is going to be minus 12. And then minus 2 multiplied by minus 2 is going to give you positive 4. And then I'm going to multiply this out. Minus 2x squared equals to 2. Okay, now we're just going to neaten up. So I'm going to put the 4 and the minus 2 together. So that'll be 2x squared. Okay? And then I'm going to put the minus 12x and the plus 3x together. That's minus 12 plus 3 is minus 9. And then 9. And then I'm going to bring this 2 to the left. So it's going to become 9 minus 2, which is going to be 7. Okay, now here you can try to factorize, or you can use the quadratic formula. I'm going to use the quadratic formula. And if we do that, we end up with x equals to 7 over 2, x equals to 1. Now we just need to go find the y values. And so to find the y values, we can come back to here. So we know that y is 3 minus 2x. So when x is 7 over 2, then we can say y will be 3 minus that over there. And so that would end up giving us negative 4. Okay? And then when x is equal to 1, this one over here, then we can say y is equal to 3 minus 2 times 1, and so y is 1. Whoa, this question is enough to give us a bit of a heart attack, isn't it? It looks weird, right? But I'm going to do my best to just show you that this question's actually not too bad. It actually works out pretty nicely. So let's try to understand. Consider the product. So that means multiply. So what they're doing is they're multiplying this, and then they're going on and on and on and on and on. So the next one would be 1 plus 1 over 5, 1 plus 1 over 6, okay? And they're just going to keep multiplying. Now, they said that each factor in the product is in the following form. So they're saying that each part looks like this, and we can see that. Here we've got a 1 plus, here we've got a 1 plus, here we've got a 1 plus, and they said that n is bigger than or equal to 2. So what that means is the first n is 2, and we can see that over there. And then the n just goes up by 1 each time. Okay, so we understand the picture, and obviously it would keep going on and on and on. Determine what the values of n can be so that the product is an integer. So let's talk about that first. What is an integer? Integers are like your normal numbers, like 3 or 5, 6, but they can also be negative. So like -2, -1, and 0. So it's all of these kind of numbers, okay? It's not numbers like 3 over 4, because that will give you 0.75. So it's all the normal numbers, like the numbers that you would count with, 1, 2, 3, 4, 5, 6, 7, 8, 9, but it's also the negatives, and it's also 0. Okay, those are what integers are. So let me show you an example. Let's say we only have n as 2. Let's say n is only 2. Then what would this give us? Well, let me show you something a bit better. I want you to just type that on the calculator. It would give you 3 over 2. If you type this one on the calculator, it will give you 4 over 3. And if you type this on the calculator, it will give you 5 over 4. And so can you see the pattern? The top numbers are just going up by 1 each time. So the next number would be 6. And then the numbers at the bottom are also doing the same. So this would just be 5. So let me show you something. In this scenario over here, can you see that this 3 and this 3 would cancel, and this 4 and this 4 would cancel, and this 5 and this 5 would cancel. So all that we would be left with is 6 over 2, and that would give you 3, which is an integer. So in this scenario, what was n? Well, n was 5, okay? So if n was 5. Now let's say if n was maybe 4, then it would just go 3 over 2, 4 over 3, and 5 over 4. So that's what you would end up with if n was 4. Now look, the 3's cancel again and the 4's cancel, but what are we left with now? Now we're left with 5 over 2, which is 2.5. So that's not an integer, okay? What about if n is 3? If n is 3, then you would just have 3 over 2 and 4 over 3. It would end over there. Okay, and now here the 3's would cancel, and you'd end up with 4 over 2, which is 2, which is an integer. So if you had to go do this experiment a little bit longer, you can try n is 6, n is 7. What you're going to notice is that whenever n is an odd number, then it ends up causing the things to cancel, and you end up with a nice answer at the end, like a 6 over 2 or a 4 over 2. But as soon as n is a even number, then you end up getting an odd number at the top here, and it ends up not giving you an integer. So it has to be an odd number, and it works, but it must be an odd number bigger than 2, because they said that n has to be bigger than or equal to 2. So n has to be an odd number than 2. Okay, so n could be 3, 5, 7, 9, 11. Then it works out really nicely. The first term of an arithmetic series is 7. The difference is 5, and the series has 20 terms. Calculate the sum. So on our formula sheets, we've got formulas for series or for sum, and we know that for an arithmetic, it's this one over here. Okay, so they tell us that they want the sum of 20 terms. So we have 20 terms. A is your first term, which is 7, and then 20 terms, and then the common difference is 5. You don't get much easier than this, guys. It's literally plug and play. So I'm just going to go type this all in on the calculator now, and we should end up with 1090. That's for 2.1.1, and then here's 2.1.2. Now it tells us that the original series is extended to 75 terms. Okay, so instead of having 20 terms, now they're going to have 75 terms. The sum of those 75 terms is 14,400, okay? Using sigma notation, write down an equation for the sum of the terms. Write down an equation for the sum of the terms added to the original series. Okay, so the original series is 1090. And that was because we have 20. Let me explain. We know that the sum, 75 terms, is 14,400. So the sum of 75 terms is 14,400. And we know that the sum of the first 20 is 1090. So they said they want us to show sigma notation for the terms added to the original series. So here's the sigma. Now we know that the total series, there are 75 terms, but because we only counting, because remember we originally had 20 terms. Now they're telling us that we have a total of 75. So how many terms are here? Well, that would only be 55 terms. So we're not going to start here we're not going to say k equals to 1, because then you are going to go from 1 to 75, and that means 75 terms. But we just want to add on from here. So we're going to count from 21. okay? And if you go from 21 to 75, that is 55 terms. Remember, to work out the number of terms, you say the top number minus the bottom number, and then you add 1. And that's going to give us 55. So we are just going to go from term 21 up to term 75. And the formula that we put over here is the Tn. So it's the Tn of this original formula. So we need, or of this original series. So we need to go find that quickly. So we know that Tn is a plus n minus 1 times d for an arithmetic pattern. And so a is 7. The number of terms, we're just going to leave that as n for now. And then d is, the common difference is 5. Okay, we're just going to go simplify that now. So it'll become 7 plus 5n take away 5, which is then 2 plus 5n. And that is what we would put over here. But instead of having a n, we would use a k. So it's going to be 2 plus, and then we can also add on one more thing. We know that the sum of these first 20 terms is 1090, and we know that the sum of everything together is 14,400. So then what would the sum of just this part be, which is this part over here? Well, that would be 14,400 minus 1090, and that's going to be 13,310. So we can add that there. Okay, and so this sigma over here is what represents this these new terms that were added over here. The sequence of first differences of a quadratic pattern. Okay, so quadratic pattern is when the second difference is constant. They're telling us that the first differences is 1, 3, and 5. So let me just give you another example quickly to show you what they're talking about. Let's say we had a quadratic pattern that goes like this. So this is the original pattern. Then this one here is your first differences. So that would be a 2, then a 4, and then a 6. You can see, okay? And then your second differences is 2 and 2. So you can see that it remains constant. That is what, so when they're saying that we have a quadratic pattern where these are the first differences. So we don't know what the original numbers are. We only know the first differences. So we could almost think of it as like X, Y, Z. Don't worry, we're not going to have to go solve all of these as unknowns. I'm just drawing a picture for you guys. So the first difference is 1, then it's 3, and then it's 5. And then the second differences would remain constant. But we don't know what the original pattern is for now. They said that term 99 is that. Calculate the value of term 98. So they want to know, they're telling us that in this quadratic pattern over here, they're telling us that term 99 is 9,632. That's term 99. And they want to know what is term 90, okay, in this pattern over here. We can't work with this pattern at all. We have no information. We're gonna have to work with this pattern over here, which is our first differences, okay? And if we look carefully, this is term 1 in this pattern, and that is between term 1 and term 2 in the quadratic. Let's just make a little summary for ourselves. T1 in the first term 1 in the differences is between term 1 and term 2 in the quadratic, and T2 in the quadratic. Therefore, term 98 in the first differences is between T98 and T99 in the quadratic. So let's go find term 98 in the first difference pattern. So in this pattern over here, let's go find term 98. So now if you are in grade 11, you can make this into a grade 11, like a linear pattern, where you would eventually get, for this pattern over here, you would eventually get something like 2n minus 1. If you are in grade 12, you can realize that this is arithmetic. Okay, and so for grade 12, you're going to get exactly the same, but you're going to use the arithmetic formula because it's a first, you can see that the difference is constant. Plus 2, plus 2, plus 2. And so you're going to end up with a, which is 1, plus n minus 1, and the common difference is 2. And if you had to go multiply this all out, you would eventually end up with 2n minus 1. So it's the same. Okay. Now, in that formula, which is for this first differences pattern, we want to go find term 98. So term 98 would then be 2 times 98 minus 1, and that's going to give us 195. Term 98 in the first differences is between term 98 and term 99 in the quadratic. So we know that that 195 would then end up being over here, 195. So then if I know that this is 9632, I can then work out what this is because I now have the difference between their two numbers. And so I can say that term 98 is going to be 9632 minus 195, and that's going to be 9437. 9437. Now this question says, if it is further given that the third term of the quadratic pattern is 32. Okay, so term 3 in the quadratic pattern is 32, so I can put it over there. Determine Tn. Okay, so we've done this so many times. So we can just go, we know that the general formula goes like this, and then we know that the bottom here is 2a, and then we know that this one here is 3a plus b, and then we know that this is a plus b plus c. Okay, but in this case, we're not going to be able to do that, but that's okay. We can do these ones so long. So if 2a is 2, then a must be 1. If 3a plus b is 1, but we already know that a is 1, so we can fill that in. This is just the normal getting a quadratic. There we get that. So we now have the following so far. A is 1, b is minus 2, but we don't have c. However, we can't go do the normal a plus b plus c as x because we don't have x. But we do know this. We know that term 3 is 32. So we can fill that in over here. We can say 32 equals, now wherever you see an n, you can replace it with a 3 because it's term 3. And then look at that, the only unknown is c. So we can then say this becomes 9, this becomes 6, and so if we then had to solve, we should eventually end up with 29 is equal to c, and so the final formula will be 1n squared. You can even just say n squared if you want. A circle with a radius of 6 centimeters is drawn, and then a second smaller circle is drawn, and then through the center of the first and also touches the first, a third smaller circle. Okay, so this is the original circle, this one here. Now that one over there has a radius of 6 centimeters. So that means that that distance is 6 centimeters, or you can think of it as that distance is 6 centimeters, the radius, okay? But I think let's rather include the other circles. So that's going to be a total of 6. Second circle is drawn through the center of the first one. Okay, so you can clearly see there then if this second circle, which I'll do in, let's do it in green, that one would have a radius of 3, right? Because this distance here would be 3. And then the third circle, which is a purple one, that would have a distance, a radius that is, this distance here is 3, so then its radius would only be 1.5. So each circle's radius is halving. Now it says a third circle is drawn. Now it says that this process continues, and it's just going to keep going on and on and on and on and on, and it's going to form a geometric pattern. So we can clearly see that we're getting to, we've got a geometric pattern over here, and it says the first question, write down the radius of the third circle. So the third circle would be 1.5 centimeters. Now it says calculate the sum of the area of the first 10 circles. Okay, so to do that, we need to go find a pattern because we can't just say that r is a half, the ratio. I can see that the radiuses are halving, but the question is not asking us for a pattern with the radiuses, or the radii, it's asking about the area. And area, it's a little bit funny because it's got a r square. All we do, don't worry, all we do is we go find the area of the first circle. Now remember, the area of a circle is pi r squared. So its radius is, the first circle's radius was 6. So that's going to give you 36 pi. For the area of the second circle, its radius was 3. That's going to give you 9 pi. Then for the area of the third circle, its radius is 1.5. And if we go type that in, we get 9 over 4. Work out the ratio now. We always want to remember, say, like, for example, term 2 divided by term 1. And so we could say 9 pi divided by 36 pi. And that will give you a quarter. If you wanted to, you could have even taken term 3 divided by term 2. That would give you 9 over 4 divided by 9 pi, and that would end up giving you a quarter as well, because obviously the ratio has to remain constant. So now we have our ratio because it's a geometric pattern. So to work out the sum of a geometric pattern, we use this formula here, for example. You can also use the other one where you have r minus 1 instead of 1 minus r. Okay, now they want the sum of the first 10 terms. So a would be term 1 of the areas, which was 36 pi. Okay, the ratio is a quarter, and then n is going to be 10 because we're looking for 10 terms. Cool. Go ahead, type that all in on the calculator. Okay, and if you get that, when you do pi, just type in pi as it is on the calculator. Don't be like 3.14. Just type in pi, and if we round this off, we should get 150.80 centimeters. Now this one says, which circle would have a diameter of 3 over 128. Okay, so let's just go make a diameter pattern now. So we have a radius pattern. We can quickly go make a radius pattern so long. Let's just clear up some space over here. So we know that the radius, or let's just say the radii, we've got 6 and then 1.5. Remember, we have those from earlier. Now remember, diameter is just double the radius. So for the diameter pattern, we just get 12, because I double that, and I double that, and then if you double that, you get 3. So that's your diameter pattern. Now they want to know which diameter is going to be 3 over 128. So we just have to go find that. Now remember, we're not going to use the sum formula. They're not asking which sum of all the circles has a diameter. They just want to know which circle specifically. So we're going to go find a specific term. So we're actually just going to use the Tn formula of a geometric. 7 is it geometric? Yes. These are halving, and you can see that these are halving as well. That is geometric. Okay, so let's just write that again. So the reason we used the Sn formula for the first one is because they wanted the sum, but now they just want to know a specific term. So you've got to understand your work quite well to know when are we using Sn and when are we using Tn. Okay, so we know that the value we're looking for, we already know that is 3 over 128. Now A, remember, you got to be careful. We're looking at the diameter pattern, so that is a 12. Don't put it as 6 because that's for the radius pattern. Okay, so there's different A's depending on which pattern you are looking at. Now the ratio is a half, because if you go from 12 to 6 to 3, you're halving each time. If you don't feel comfortable with that, just say that the ratio is term 2 divided by term 1, which is then 6 over 12, which is a half. Okay, so, and then n, we don't know, so it's like that. Okay, now please don't multiply these two together. You can't, because there's a n minus 1 there. But this 12, we can take it to the other side by dividing. We can say 3 over 128 divided by 12 equals to that. Okay, and that's going to give us 1 over 512. And that's going to give us 1 over 2 n minus 1. Okay, so multiple ways we can go ahead now. But this 512, you would want to break that down using the shift fact method. So let's just clear up some space over here, because 2 to the power of something gives us 512. So type in 512 and then say equals and then say shift fact, and it's 2 to the power of 9. So 1 over 2 to the power of 9 is equal to 1 over 2 to the power of n minus 1. Oh, there's so many different ways students can think about this, but one of them, okay, let's take, there's different ways, and obviously the easiest would be if I was talking to each of you individually, because each learner is so different. But one of them is, one way is we could take the 2 to the 9 up to the top. You could even use logs right now if you wanted to, but we could take the 9 to the top, and then I'm going to do the same over here. I'm going to take that 2 to the top. All I'm going to do next is just multiply this with that. So we end up with 2 to the negative 9 equals to 2 to the negative n plus 1. It becomes negative n plus 1. Okay, now we can get rid of the 2's because they're the same on both sides. And then you can do whatever you need to do, but you should eventually end up with n equals to 10. So which circle has a diameter of that? It's going to be the 10th. Given that f of x is this graph over here, so now that is an exponential, right? Because it's got the x as the exponent. A is a positive number. B is a point that is on that graph f. This question says calculate the value of a. Now that's an easy one, because all we do is we can just say that f of x is equal to a to the x take away 1, and then we can just go plug this point in, because we know that that is x and that is y. We can just say negative 5 over 9 equals to that and that. Okay, now I'm going to take this minus 1 over to the other side, so it becomes minus 5 over 9 plus 1. Now this I would just go and type on the calculator, but it's going to give us 4 over 9. And then to get a alone, we take the square root. And so we're going to say plus and minus the square root of 4 over 9. And that would give you plus or minus 2 over 3. So a can be positive 2 over 3 or negative 2 over 3. However, they did tell us that a must be positive 0. So we can just say, therefore, a is equal to 2 over 3. Sorry, a must be bigger than 0. Not a must be positive 0. A must be bigger than 0. So a would just be 2 over 3. Okay, we'll just say here 2 over 3. This next one says, write down the range of f. So we know that range is all the y values, but now it could be quite tricky, right, if you don't know what the graph looks like. I mean, how are you going to know what the range is? Because for an exponential graph, you get many different shapes of that. You could get this one that goes like that. You could get one that goes you could also get ones that are flipped over. You could get ones that go like that, or you could get one that does. So what I think I want to quickly do is just take as little time as possible, and I want to just quickly give you a brief summary on how to know, simply by looking at this a value, whether it's going to be which of the 4 different types it'll look like. Okay, it's pretty straightforward. So just give me a bit of time and I'll quickly explain that for us. Okay, so here we go. So let's just go look at a basic, okay, I'm not going to put like a plus or a minus anything over here. That part's pretty easy to deal with. Okay, so because the thing that bugs me a little bit is some teachers, they like, if this number here is a fraction, then it means it goes down. And if this number is a normal number, then it means it goes up. It's not true at all. It only works some of the times, and the examples that the teachers use in class makes it seem like what they're saying is true, but I'll disprove it very quickly. In scenario 1, we're going to let a be any number that is positive. So it's any number that is bigger than, actually we're going to make it bigger, any number bigger than 1. So for example, we can let a equal 2. Okay, so then you're going to get y equal 2 to the x. When you get a scenario like that, then you're just going to get the basic graph that just goes, okay? And of course it can be moved up or down. It could even start down here. It could even start all the way up here. That is just going to be based on whatever we put that moves it up or down. But the point is the shape is going to be start low on the left, end high on the right, okay? But it could also be down here, could also be all the way down here, it could even be up there. The point is, it starts low on the left and ends up high on the right. Okay, that's what that shape does. In the second scenario, we want to let a be any number between 0. I don't know why I'm writing all the way down there. We want it to be anything between 0 and 1. So any number in between that. And those kind of numbers are usually much nicer or much better to represent as fractions. For example, 1 over 3, 2 over 3, 1 over 4, something like that, right? So if that does happen, then the kind of shape that we get is going to be starts high, ends low. So like that, okay? I'm just going to draw it a little bit better. Starts high, ends low. It could also be shifted lower or even lower, or it could even be right up at the top over here. That all depends, once again, on whatever you have to put over here. You know, you get that asymptote. That can be shifted up or down. But that's not that difficult. What's difficult, or what you need to remember, is if it starts high, ends low, or starts low, ends high. So this, for example, will be like, let's actually just say here, starts low, ends high. If you're going from left to right, okay? Then this one over here starts high, ends low. Now some of you are like, see Kev, our teachers are right. They told us that whenever it's a fraction, then it's going to look like that. But it's not true, because all I actually want, the only thing that makes this true is when the number is any number between 0 and 1. So I could contradict, or I could prove your teachers wrong by simply I could come back to this example and I could say, okay, I don't want a to be 2. I actually want a to be 5 over 4. Because if you go type in 5 over 4 in your calculator, it's 1,25, which is a number bigger than 1, and it'll actually have this shape. But it's still a fraction. So the whole idea that a fraction is what determines the shape is not true. It's whether the number is between 0 and 1. That'll make it look like that. Okay, it's got nothing to do with the fraction. It just so happens that fractions, we often like to use fractions in between here, because it's going to look a little, okay, I'm not going to go on and on. I think you get that idea. Now let's go on to scenario number 3, where, let me just think how I want to word this. Okay, it's when a will be any number smaller than negative 1. So now we're going to go into the negative domains. So what happens now is, let's say, for example, say, I can't even remember. Do we say EG or EX? I think it was EG, hey? Now we say, I'm trying to say example. Now we say, for example, let A equal -2. So then you're going to have an equation that goes y equals to negative 2x. That negative, I immediately want you to think of taking either this one or this one and flipping it over the x-axis. So you're going to flip it over. Okay? So in this scenario here where you just have a number that is it's the exact opposite of this one. So it's the exact opposite of this scenario here. So it's just going to be the flip over version. So where this one, the original one went like this, as I see over here, now it's just going to be the flipped over version. So it's just going to do that. Okay. So it's going to go downwards like that. Now I'm not going to say starts high, ends low, because then you might think it's this one. It's the flipped over version of this one. And then the final scenario is going to be the opposite of this one. So it's going to be when A is any number that is, it's smaller than 0. So it's something negative, but I don't want it to be too negative. I want it to be bigger than -1. So it's any number between -1 and 0. Okay, any number between -1 and 0. So for example, it's like the negative of these numbers. Okay, it's like -1/2 or -1/4. Okay? So it's between, on a number line, it would look like this. It's all the numbers that are between -1 and 0. It's all of these ones. Okay, and then for this one here, it is all the numbers between 0 and 1. So it's all of those. And then for this one, it's all the numbers that are bigger than 1. And then for this one here, it's all the numbers that are smaller than -1. So that would be from -1. That would be all of those. Okay, so right. So it's going to be, what we're now going to have is we're going to have it's the exact opposite of this one. It's the negative or flipped over version of that one. So this point over here is going to be flipped all the way down to the bottom there. So it's going to be here. And then this point is just going to be flipped over there. It's like a mirror image over the x-axis. And so you're going to get that. Those are the 4 main shapes that we get for exponentials based upon what this a value is here. So don't think about it as fractions or not fractions. What's important is the number, bigger than 1 or smaller than 1, and is it negative, is it positive? Those are the important things, the parameters. Okay, and then of course we can just draw what the original graph looks like, which is the flipped over, or it's this one over here. Okay, so those are the 4 different scenarios that we get. Let's go back to our example. Okay, so we now have our 4 scenarios, right? So they told us that A is any number bigger than 0, but that doesn't really help us because that means that it could either go like this or it could go like that, okay? But we worked out A as 2/3. Now that, if you type it in on your calculator, it's like 0.67. So it's between... It's the scenario that is between 0 and 1. So it's this scenario over here. So that's what the basic shape is going to look like. Okay. But then we also have this -1. Now what that -1 does is it just moves everything down. So normally this x-axis would be our reference point and we would draw our graph something like that. But this -1 is going to move all of that down by 1. So we're now going to have an asymptote down here at -1. Okay. And so we're just going to draw it now relative to that. Now we don't really know where it's going to go through the x-axis. That's not important for range. I'm not saying that it's going through that point 0. I'm just giving you the rough guideline of what this graph's going to look like. Let's actually make it a bit better. It goes down. The point is the range. So the range is the y values. So it's going to be all the y values from -1 all the way up to infinity, right? So there's multiple ways, or there's 2 ways we're going to write that. You could either say y is an element going from -1, we don't include the asymptote, all the way up to positive infinity. Or the other way that you could write that is you could just say that, the other way you could say it is y must be any number bigger than -1. You don't have to give both of these in the exam. Some learners prefer interval, some learners prefer set builder notation. It's your choice. And this graph this question, they want us to now sketch the graph. So we've already gone and put the asymptote in. Okay, so remember, to draw a exponential, what we do is we always start with the step 1, we go get the y-intercept. And to do that, we make x 0. And we see if there's an x-intercept. Sometimes there isn't, so I'm going to put a question mark here. And then asymptote. Then point number 4 is if no asymptote, then another point. But you only have to do step 4 if there is no x-intercept. Kevin, what do you mean there's no x-intercepts? Or don't all graphs have x-intercepts? No. Check this one. It's got no x-intercept. Or what about this one? That's got no x-intercept. Or what about this? It doesn't have to have an x-intercept, right? So let's go check. So to find the y-intercept, we make x 0. So we take our equation and we make x 0. Now, a lot of learners, they just write this off. They think that this part here is going to be 0. But anything to the power of 0 actually becomes 1. So it's going to be 1 minus 1, which is 0. So the y-intercept is at 0. And then x-intercept. How do we do that? We make y 0. So where's our... Okay, so I'm going to take this equation. I'm going to make y 0. I'm going to take the 1 over to the left. So we end up with this. Now, I know that grade 12s, if you want, you could definitely try use logs here. It will work, but there's an easier way. Grade 11s especially. We know that anything to the power of 0 gives us 1. That means x must be 0 so that this whole side and this whole side will be equal. So solve it how you want, either just by saying doing what I did there, or if you're in grade 12, you can use logs if you want, but the point is x is going to be 0. Okay, so we do have an x-intercept, and then, but it's not a very nice x-intercept because it doesn't really give us a new value. Usually we like these two to be different because then it's very easy to draw your graph. Imagine we have this, and we have this, and we have that. And it's very easy to, but now you see we don't really know if it's going to do this or that. Yes, we do, because I've gone and I've explained all of that, what the A value does. But if you maybe forgot in a test, you might be a little bit stuck and think, I don't know if it's going to go this way or if it's going to go this way, because the X and the Y are on the same place. So we didn't really get two different places. You know what I mean? So then what you could do, and we should go do the asymptote, which we have. So then what you can do, if you forgot what the different A values, what the shapes that they make, the exponential graph, if you forget that in the exam or the test, then what you do is you move on to step number 4, which is find another point. How do we do that? That's an easy one, actually. You can just let x equal, let's let x equal to 1, for example. If x is equal to 1, then remember our original equation goes like that. If x is 1, then you're just going to get that and that. And if you had to go solve this, you're going to get negative a third. So when x is 1, which is like, y is negative a third, which is like, and so now if I connect those two, I get a much better idea of what my graph. And so sketch the graph, clearly show the intercepts. Okay, so we have to go label those, 0, 0. And then you don't have to label this point. I would, though, just to be safe. They didn't technically say any other points. They just said asymptotes, but let's just label this to be safe anyways, because you would show them this part. So if x is 1, then y is negative a third. Okay. Let's move on now. If it is further given that C is a point on F at y equals to 19 over 8. Okay, so 19 over 8, if I was a student, I would immediately just type that in on my calculator just to get an idea. Okay, it's 2,37. So it's somewhere up here. So I know that the y value is there. So where is that on my graph? Well, the y value on my graph, okay, so that's the point that they're talking about, because that's the only place on my graph that has that y value, and I know that that's points. Now determine the coordinates of C prime. Now grade 12s, that's not the first derivative. I know there's grade 11s watching this as well, but if you are a grade 12, that is not, they're not meaning first derivative over there. Okay, so it says determine the coordinates of C with a line which is the image of C when C is reflected across the line y equals x. So the line y equals to x is a diagonal line like this that goes through the origin, okay? And all that happens when you reflect something across the y equals to x line is the coordinates switch. So for example, if you had a point over here which was like 3, if you reflected across that line it ends up becoming 2. If you have a point, let's say over here, which is -1, -3, when you reflect it that way across this line, then it ends up becoming -3, -1. So you just switch the coordinates around, okay? Let's neaten up a bit. I'll make a little rule for you guys now. Okay, so the line y equals x is a diagonal, okay? And no, it doesn't go this way, it doesn't go that way. It always goes in the direction that I've drawn it. So it always goes from the bottom left to the top right like that, through the origin. Okay, now when a point reflected across the line y equals to x, all you do is switch. With point C, we already know its y value. We already know its y value was 19/8, but we don't know what its x value is. So we can't really switch the coordinates to find the C with a line because we don't know what the x value is. But that's okay, because if we have a y value, we can easily get the x value if we have the equation of the graph, which is this graph over here. Now we have that equation. That equation is y equals to 2/3x take away 1. So we know the y value is 19, but we don't know what the x value is that goes with. So I'm going to take this -1 over to the other side, and it's going to be 19/8, which is 27/8/3. Now, if you are in grade 12 watching this, you could easily just go use logs immediately right now. But if you're in grade 11, what we can do is, I recognize that these numbers here, these two numbers, they look very familiar. They look like cube numbers, you know, like 3 to the power of 3 is 27 and 2 to the power of 3 is 8. So I'm going to rewrite it as 3 to the power of 3 over 2 to the power of. Now, when you have something like this in maths where both of these numbers are raised to the same exponents, and what we can do is we can just make it fraction to the power of that exponent. And this is equal to 2/3x. Now, we know that in maths, if your two base numbers are the same, then you can cancel them. For example, if we have like 4 to the x plus 2 equals to 4 to the 9, then we could actually just cancel those 4's out, and then you're just left with x plus 2 equals to 9. The problem is that these two are not the same, but they're very close. They're very close. So what we can do is we're going to flip. Either you're going to flip this one upside down, or you can flip this one upside down. You can choose whatever you like. It's completely up to you. I'm going to flip this one upside down. But to do that mathematically, I don't just flip it. I know that whenever I flip something in maths, like if I have a 5 and then I want to write it as, well, how do I say this nicely? So for example, if I have, what's a nice, I don't know, I'm trying to think of a nice way to explain this. We need to remember that if you flip this around, then its exponent must change sign. So this exponent here was a 3. Now it must become a -3. If it was negative, then you would change it to a positive. So as soon as you flip these around, then this exponent has to change sign. Now, the reason I've done that is that now, all of a sudden, we have the same base, 2/3 and 2/3, so they can cancel out, and then we just left with. Okay? So now we know the x value of this point, this x value is. So now we can actually go and do the question where they now want us to flip it over the line y equals to x, and what we said, when a point is reflected across the line y equals to x, switch the coordinates. So the coordinates are now going to become 19/8. Sketched below is the graph of f. Okay, so that is a hyperbola, which has the domain from -infinity to 1 and from 1 to infinity. That's actually a nice little clue over there, but we'll talk about that just now. And the graph of f cuts the y-axis at 0, 1, which we can see over there, and a line of symmetry is given by that equation over there. So this is the symmetry line. Remember that a hyperbola actually has two symmetry lines, but they don't have to show both of them. They don't have to show any of them. They do have to show the asymptotes, but symmetry lines aren't normally shown, but here they have given us this one over here. This first question says, write down the value of p. So p is over here. So what we must remember in a hyperbola is that part over there with the x, this part here, that part there tells us whether the graph has moved right or whether it's moved left, okay? And then this part over here is the part that tells us whether we've moved up or down. So if we look at this asymptote here, that asymptote there tells us if we've moved left or right. Because from grade 10, we know that a normal hyperbola would just look something like this. It would be there and it would be there, for example. You would just have your x-axis and your y-axis. Well, that is how a normal hyperbola looks. Yes, in grade 10, we could also move it up and down. But in grade 10, we never moved left and right. But the point is that you can see that the asymptote is the y-axis, okay? But now we can see that the asymptote is over here. So it means that the entire asymptote has been shifted to the right by 1 unit. That means the entire graph has been moved to the right. When a graph has moved one place to the right, then it should say x minus 1, because putting a minus over there means that it's moved one place to the right. If you then look at what they had, x plus p, and what it's supposed to be, then you can easily see that p must be -1. But sometimes in an exam, they don't put x plus p. Sometimes they write the equation with x minus p. That's okay, because then they would have x minus p, and we know that it's supposed to say x minus 1. Then you can look at them and be like, oh, okay, so the minuses are the same for both. So that means p must just be a 1, because the minus is already there. Okay? So then p would just be 1. But because they gave it like that, but we want it to be like that, because this is the example we have, then it means that p must actually be -1. Okay, and so, yeah, I hope that that part makes sense. They can change this part up. They can make it x minus p or x plus p. That part doesn't matter. They are allowed to do that. It's not wrong or right, but you need to know what it is supposed to say at the bottom. We know it's supposed to say x minus 1, and then you just compare it with what they've given you, and then you can determine what p has to be. Okay, now the next one says, determine the equation of the horizontal asymptote. So the horizontal means this. Now, we know that that's going to have the equation y equals something. So we got to now try think what that is going to be. So can you see that we know the equation of this line? Okay, they told us that that is y equals x minus 3. I know that this point over here could easily work out that point's y value, because I know the x value on this line. I know that this x value on this line is always going to be a 1 anywhere on that line. That is the asymptote, x equals to 1. So if I can find, so then I know that at this red dot, x value is 1. So then I can plug that x value into this line to find the y value at that point. Okay, how would I do that? By just plugging the x value into this equation. So that's going to give us y equals to 1 minus 3, which is -2. So I know then that the coordinates of that red dot is 1 and -2. So the y value is -2 on that dot. Wouldn't that be the same y value anywhere on this horizontal line? Because the y values don't change when you move horizontal. So I then know that the y value over here, or here, or here, or here, anywhere on that dotted line is -2. And so that is the answer. The y values on that line are -2. Now it says calculate the value of a. And by the way, because we now know that this graph has a horizontal asymptote of -2, it means that the graph was moved 2 places down from its original. Remember, an original hyperbola would look like this, but now we can see that by this dotted line, we've moved 1 place to the right. So let's modify our graph, 1 place to the right. Oh, and we're not in these 2 quadrants, we are in quadrants, okay? And then we can also see we've got a dotted line here, so we've moved 2 places down. So let's just go 2 places down, and then we can draw a graph. So we've moved 1 place to the right and 2 places down. So now we know this coordinate over here is going to be, well, this value here is going to be -2. So f's equation is going to be a over x minus 1. So to find the value of a, we need to substitute any point on that graph. So if we look here, we don't have any point. If we look here, we've got this point over here, which is the y-intercept, which would be x0 and y1. So x0 and y1. So I can go plug that into this equation. And so now what we get is 1 equals to a over -1, take away 2. Now this part here just becomes -a. Okay, so I'm going to then take this over to the other side. So we end up with a, and then I'm going to bring the 1 over so it becomes -1. So a is -3. I can then put that over there is the equation of that graph. This question over here says, for which values of x is f of x bigger than or equal to 0? So what that actually just means, if they say f of x bigger than or equal to 0, what this means is where is f, or where is the graph above? If we highlight the x-axis, where do you see the graph above that? Well, I can see it above over here, and that's actually all. We won't say here because that's not the graph. That's a symmetry line, which is not, that's not part of the graph. The graph is only this part and that part. So that is the only area where we can see it is above 0. It's from, right, that's where it started going above the x-axis. But now the thing is, we don't know what that coordinate is. It's not the 1. The 1 is for here. We don't know what that is over there. But that is the x-intercept of that graph. So we can go find the x-intercept of that graph by making the y value equal to 0. Because to find any x-intercept, we always make y. So we can then say 0 is equal to a, which is -3, over, what was our equation? X minus 1. Hey, multiple different ways we could solve this. So you don't have to do it the same way I'm doing it. I think what I want to do is I'm going to take this -2 to the other side, and then can think of it as 2 over 1. So now I'm going to cross multiply. So I'm going to multiply the x minus 1 up to the 2. I'm going to multiply the 1 up to the -3. So we end up with 2 bracket x minus 1, and then on the other side -3 multiplied by 1, but that is just going to be -3. But anyways, let's leave it there. So now we're going to multiply the 2 into the bracket, so we end up with 2x minus 2 equals to -3. I'm going to take the -2 to the other side, and then we're going to divide by 2. And so don't say the answer is x equals -2. It's actually going to be x equals to -1/2. So that is the x value over there. Okay? Its x value is -1/2 and its y value is 0 because it's the x-intercept. Okay, so we said where is the graph above the x-axis? We said it's for this little area over here. So you could say, now there's two different ways of writing this. You could say that x is an element going from -1/2. We are including the half, or the -1/2, because they have also included. But now we're going to go all the way up to this dotted line, which is the asymptote, and we never include the asymptote because the graph never touched. Let me just quickly explain something. And sorry, if you want to write it in a different way, you could say that x is bigger than or equal to -1/2, and then what am I doing? Smaller than or equal to 1. You can either write it like this, or you can either write it like this. I just want to quickly explain how I got -1/2 and 1. So they wanted to know where's the graph above the x-axis. So we said it's that area there. But when you give your answer, you have to use the x values. So you see how it's going from there, dotted line. It's inside that little area that we're giving the answer. So we're going from x value here, which is -1/2, up to the dotted line, which has an x value of 1. So it's that little area there. So, okay, now this question says, graph f undergoes a transformation to become h. Say, where the domain and the range are the same as f. Okay, so h has the same range and domain. Okay, fantastic. With a line which is the derivative is negative on its domain. Don't worry, that's actually really easy. I'll explain that to you now. Describe a possible transformation that could have undergone to result in h. It's actually a very easy question. Let me show you something about gradient and hyperbolas. We know that gradient, for example, if I show you a parabola, you can see that this area here, would you say the gradient is negative or positive? Well, the gradient there is negative, right? Because as we move from left to right, you can see the graph is going. So it's got a negative gradient. Now, in this area here, you can see that the graph is going up. So the gradient is positive. So the parabola has a negative and a positive gradient at certain places. Hyperbolas, however, they have, depending on the type of hyperbola, you get two types. You either get the quadrant 1 and quadrant 3 type, where if you look at the gradient, it's actually going to be negative everywhere. If you look at this area here, see the graph's going down. You can see as you go from left to right, the graph is going down. And then as you look at this area here, the gradient is actually also going. So this graph here, the gradient is always negative. If we have a quadrant 2, quadrant 4 kind of hyperbola, which is the kind that we have in this question over here, we can see we've got like a there and we've got a there. We don't have there. Here we can see the gradient is always positive, because if I look here, we can see the graph is always going up. And we can see that as I go, remember, whenever we look at this, we're always moving from left to right. So as I go from left to right, I can see the graph is going in an upwards direction. So the gradient is positive. So here, the gradient is always positive in this graph. And here, the gradient is always negative. So in this one over here, we've always got a positive gradient. Can you see that if I draw a tangent line at any moment, always going positive, even over here? See the tangent line, the gradient of the tangent line is always a positive. Remember, positive looks like that, negative looks like that. So that's how hyperbolas work. They always have the same gradient for a specific graph. So this one has always got a negative gradient. this one always has a positive gradient. In this question that they've given us now, they said that graph f undergoes a transformation to become a new graph called h. The domain and range are the same. So that sort of tells us that, or let's actually also just read the next part. They say that the derivative, which stands for, is always negative. But this one we can see that the gradient is always positive. Okay, so it means that new graph h is definitely going to be in quadrant 1 and 4. So it's definitely going to be like and there, because then we can see that the gradient is always negative for that one. It might be like some type of reflection, but we got to be careful. We can't just say that, for example, it's a reflection across, or let's actually see, could we maybe say that? Yeah, we could say that it's a reflection across this line. We can see that that's all that's happening. It's a reflection across this line over here. Some of you might say, can't we say it's a reflection across the x-axis? No, because then this line over here is also going to be reflected, and it's going to land up here at y equals to 2. So your asymptote's going to be like this. And that will affect the range. The range will then change, and they said that domain and range have to stay the same as they were originally. So by reflecting across the line y equals to -2, we can see that this part over here is simply just going to reflect and jump to become this part over here, okay, like a mirror image. And then this part over here is just going to jump downwards over this dotted line to become this part over here, the mirror image over there. This asymptote itself won't change because that's the line that we are reflecting over. That won't change the domain or the range or anything like that. So we can say here that it is a reflection across the line y equal. Some of you might have even noticed that we could even, that's one way we could have done it. We could have actually just reflected across this line over here, this asymptote, because then this part over here, if you reflect it across this line, the mirror image just becomes, I didn't draw that, but it just becomes that. And this part over here would end up reflecting that way, and it would just become, and so we still achieve the exact same goal, where we now have a quadrant 1, quadrant 3 scenario where the gradient is always negative, which is what they wanted, okay? But we haven't changed the domain or the range. So that is your other option. You could have said a reflection across the line x equals 1. In the diagram below, the graph of f, okay, so let's go highlight that quickly. So the graph of f is this one, and g, straight line are drawn. Okay, so G is just the straight line, which is that one over there, are drawn. Point C, which is at 3 and 8, is the point of intersection. EH is drawn parallel to the y-axis. Okay, that sounds like a minimum maximum. Oh, hello. And okay, there, everything else is fine. First question for 3 marks says calculate the coordinates of B, which is the turning point of that. Okay, multiple different ways. You could just simply use the -b over 2a formula. That's my favorite. Number 2, if you are in grade 12, you could use, to find turning points, it's to find the maximum. You could take first derivative, make it equal to 0. And then if you really feel like a challenge, but I really don't advise this, I don't know why some learners still use this method unless they tell you to, but that is completing the square. You don't want to have to do that. Completing the square is a way to take this equation and turn it into something that would maybe look something like, I don't know, maybe that, for example. Because when you have, let's say that, because when you, or let's make it 12, because when you have this, then we know that the turning point is going to be 3 and 12, for example. That is how you go from that. It's by completing the square. But I don't like that because completing the square is horrible. So I wouldn't do that. I would always just use this one or this one. Okay, right. Now let's actually do it. So I'm going to use method 1 because it's applicable to grade 11s, grade 12s. And so very easy. We know that it's just going to be x of the turning point is equal to that, and so that's going to be negative. Now b is 4, and then a is going to be -1 because it's whatever's in front of x squared, and that's going to end up giving us -4 over -2, which is 2, and so the x value over there must be a 2. Now how do we find a y value if you have the x value? All you do is you plug it into the equation. So if you plug in 2, you're going to get... Now, a lot of learners mess this part up. That negative is not part of the square. If it was, they would have done that. That negative is just chilling in the front, so you're going to do that. Then you're going to open up the bracket, and then put the X value. Okay, it makes a massive difference. If you're Afrikaans, dit maak 'n moer verskil. I'm not Afrikaans, but I just know that sounds quite funny. I remember there was like a funny TikTok or something, or I don't know if it was my like December holiday last year. I was up in this area north of Durban. It's like very Afrikaans, and they were talking about Hilux bakkies, and dis 'n moer se lekker bakkie. Okay, let's move on. So it was actually quite funny. Let me share the story. So me and 3 other friends, well, my brother and then 2 other guys, we went up to a place called Sodwana, a fishing village up north of Durban. Why we went there, it's a long story, but yeah, it was very funny when we were there because it's a very Afrikaans fishing area. Like everyone there drives like Hilux bakkies or Land Cruisers. And then us English guys, we rock up there in a Suzuki Swift. And yeah, it was quite funny going into the like little pubs there, all the Afrikaans guys there, and they're like, yes man, lekker man, Roy Nikki, wat maak jy? And I'm like, I'd like a Coke, please. Anyways, yeah, I heard them saying there's a lekker moer, so lekker Hilux bakkie. Okay, anyways, let's move on. So, ja man, jy gaan nie net so Coke drink nie. Soek jy 'n bietjie brandy ook? No, I would just like an Oros, if that's alright with you. Nee man, jou rooi nek. Kom, jy gaan lekker brandy drink. Okay, Kevin, come on dude. It's like PG-18, dude. Okay, so where are we? Okay, so we're gonna go type this in on the calculator. F of 2, and it should eventually end up giving us -4 plus should give us 9. So the y value here is 9. That makes sense because the y value here is 8, and it is a little bit higher up. And so, yeah, you get 2 and 9. I'm still laughing at my jokes. Okay, so calculate the coordinates of B. We've done that. It gave us 2 and 9. Okay, now this question. Show that the equation of the line that goes through A and C, okay, so this line over here, is given by this equation. Now, a lot of learners, they like, oh, so I'm just going to take this equation and I'm just going to use this one, and then I can like sort of show. Guys, you can't do that. They want us to finally show that this is the answer. So leave that alone for now. Okay. Yeah, but sir, even the person that set this test, I could even bench them for a warm-up if I wanted to. But anyways, I won't use this equation, whatever. Okay, let's move on. What we can do is we know that it's a straight line, and we know that to find the equation of a straight line, we need 2 points. So we've already got that point, which is fantastic. So we need this point, but that is also the x-intercept of the yellow graph, this one over here. So we can go find the x-intercept. How many x-intercepts does the yellow one have? 2. So we are going to get 2 answers when we solve this. Don't be surprised. So if we take that equation, okay, now to find x-intercepts, we make y 0. So I'm going to make y 0. Now there are so many different ways to solve this next part. You could use the formula immediately. What I like to do is I'm going to take everything to the left. So I'm taking this to the left and everything else to the left, because then I end up with that. I end up with no negative in the front. Yes, you could have just divided by -1, but some learners aren't comfortable with that. So I'm trying to make it the easiest way possible. Now here you could use the formula, the minus b plus minus. You know this formula here. This is actually my signature. Did you know that? When I'm at like a bank or signing for something, they're like, hi, can we please have your signature? Then I'm just like, oh, sorry, I'm just so used to doing maths all my life. Sorry, you want my signature? Oh, okay, here it is. I'm going to show my real signature, but that's just a smiley face. Okay, wasn't funny. So let's go. So you could either use the formula or you could factorize. So I'm going to factorize this one. Not all of them can factorize. But yeah, this was a pretty straightforward one. So that's factorized over there. And then you'd get x equals to 5 or x equals to -1. So this is obviously x equals to -1. And then this would have to be x equals to 5. So now we know this coordinate. It's -1 and the y value is 0 because it's on the x-axis. So now we can easily go find the equation of the straight line. We can, and there are other ways of doing it. Some of you may have seen your teacher using this type of formula. If you haven't, don't worry. We don't even have to go there. Pretend I didn't even show you. What am I even talking about? Okay, so let's go find the gradient. So to find the gradient, we use the y2, take away y1, over x2 take away x1. And right, so I'm going to use this as coordinate 2 and this is coordinate 1. You can do it the other way around. It really doesn't matter. So if I go plug in now, I'm going to plug in 8 take away 0 over 3 take away -1. That ends up becoming 8 over 4. So we now have the gradient of that line. To find c, we plug in any point on that line. We can plug in 3 and 8. So the 8 is the y, 3 is the x, and so 8 equals to 6 plus c. Get c, I take the 6 over to the other side. So 8 take away 6, and so c is 2. And so therefore that equation would have to be y equals to 2x plus 2. So let's just go, show that it was that. Haha, we did it. Well done, guys. Okay, so next one. Okay, now this one says calculate the maximum length of EH. Okay, so calculate the maximum length. Now, I've showed you guys how to do this. All you do, whether they said minimum or maximum, all you're going to do is you're just going to say y top minus y bottom, and that is going to give us the length of EH. What do I mean by that part? Let's say, for example, I had a different scenario where I had a graph like this and I had that, and I wanted to work out this length. And let's say, well, let's actually make it a little bit easier. Let's say I have something like that and I had something like that, and I want to work out this length over here, for example. Get a dot, dot, dot. Now let's say the y value up here is 4 and the y value over here is 1. Then obviously their x values would be the same. So maybe the x value is 2, and this x value would also be, but let's say the y value was 1. Then wouldn't you agree with me that this vertical length over here, you could just say 4 minus 1, just the y values. That's the only, to go from that dot up to that dot, it's just going to be 3 places up. And so that length would be 3. That is what I'm saying when I say take the y value at the top minus the y value at the bottom. So 4 take away 1 is 3. That's the idea of why we say y top minus y bottom. We take the y value of E minus the y value of H. So it's the y value of graph E minus the y value of point H, which is going to give us that length that we are looking for. So the y value of point E is on this yellow graph. So we're going to go replace the y value with the graph's equation. So minus x squared plus 4x minus. Now the point H is on the green line, and we now know the green equation, but you must put it in brackets whenever you are subtracting, and that's going to give us the length of EH. And so we're just going to go simplify a little bit now. That minus goes into both to become negative. We're not going to put 0 here. We're just going to keep calling it EH because that's the length of EH. I'm now going to go simplify. So this 4x and this minus 2x just becomes a positive 2x. And then 5 minus 2 is going to be positive. Okay, so we now have an expression for EH. Are you comfortable with the fact that I can also just rewrite it with the EH on the left, right? That's fine. I just did a flippity flip. But maybe you're not comfortable with that. Maybe you like, Kev, Brew, when you take this EH to the left, doesn't it become negative EH? Yeah, you could say that. And then when you take all this stuff to the right, won't it just be like change, Brew? So like minus x squared will become x squared. This will become minus 2x. This will become minus 3. Yes, that is correct. But then if you want to get EH alone again, and you want it to be positive, we divide everything by -1, and so the signs flip back again, and so you actually just end up like that. So if you have x equals to 3, you are also allowed to write it as 3 equals to x. It's the same thing. Okay, cool. So we now have an expression for EH, which is this vertical length that we are looking for. Now we are looking for the maximum length. If you are in grade 12, you are more than welcome to use calculus right now and do the whole first derivative equal to 0, the way we find maximums or minimums, right? However, if you are in grade 11, and even if you are in grade 12, the other way of doing it is the following. I want you to completely forget about the rest of all these questions, everything we've done, completely forget about it. If I came to you one day and this was the only thing I showed you, I just said, Awe, Owens, Keiki, I want you to find the maximum here. Okay, so we have EH equals to minus x squared plus 2x plus 3. So so forget about the rest of the question. I now come to you one day and I'm like, I have this equation. Can you please find the maximum of that equation? Well, what you would identify, what type of graph is that? That is a parabola. and it has a negative, so it means it's a parabola that looks something like that, right? How do you find this maximum up here? How do you find that point? Isn't that point simply called the turning point? So how do I find a turning point when I've got this equation? Well, all I do is I just use x equals to negative b over 2a, don't I? And that's going to give me negative 2, because b is 2, over 2 times negative 1. And so that's going to end up giving me negative 2 over negative 2, which is 1. That is just the x value of that point. How do I find the y value? Well, I then take that x value and I simply plug it into this equation. And so when you plug in, this negative mustn't be included in the bracket. So it would look like that. And that's going to give us 4. And so there we have found the maximum value of the parabola, which is called EH. So we have answered the question. It says, calculate the maximum length of EH. I gave you the equation of EH. It was a parabola equation, and you went and solved it. Done. Finished. That's the answer. We got 4. Got nothing to do with, once you've generated this equation, you just work on that equation, okay? There are other ways. What you could have done, when you found that the x value was 1, you can then come back and plug it into this one's, you can plug it into this one's equation, and then you can plug it into this one's equation, and then you can minus them. But that's exactly what this is doing over here, and that's exactly how we made that equation over there, and that's why we don't have to do it that way. We can just work on this equation over here. And for those of you that just want a little bit of a deeper understanding about why we have a maximum length, well, if you look at this area between the two graphs, can you see that area there? If you look at that area there, that's quite a small length. And it gets a little bit bigger, then it gets a little bit bigger, then it's really big over there, and then it starts getting a little bit smaller again. Can you see that? So it makes sense that the maximum length is exactly there where they were showing us the dotted line. You can see that the vertical distance between the two graphs is the maximum. And what we found was that the x value is 1. So this x value is going to be 1, okay? So that is what we've done there. And then we went and calculated, if we know the x value here is 1 and the x value here is 1, we then went and plugged it back into our formula for EH, and we found that this length is 4. This question says, given that k is equal to... Given that k is equal to that, okay, getting fancy over here, determine the value of m, oh my word, such that g is a tangent to k. Okay, now I promise you, when I read that, and I don't look at the memos before I do these questions, right? So I'm reading that fresh right now. That looks absolutely shocking. It's absolutely terrible. I know from experience, and I know that if I just stick to certain principles and I just start somewhere, I can usually start working through it, and I don't have to aim for 5 marks. Even if I get away with 3 out of 5, that's perfect, okay? But of course, I'm going to show you exactly how to go for the 5. But let's just think about this carefully. They're saying, given that k is equal to f x plus m, okay, I'll explain that part now, and then they say that it's equal to that, okay, so they're even telling us what the equation is, so we don't have to go do that. They didn't necessarily have to give us this part. They could have just said that, and then what you would have had to go and do is, if I say what is f of 2, how would you work that out? You'd go plug 2 in all the x's, right? If I say what is f of x minus 3, then you would go plug x minus 3 into all the x's. If I say what is x plus m, you would go plug x plus m into all of the x's, and it would have ended up looking like this. They then went and simplified that for you, nice, kind people, and this is what they ended up getting, okay? They've done that part for us, but they didn't have to. So in a future question, just be aware of that. So they've given us what that equation becomes if you plug x plus m into that. It says determine the value of m such that g is this graph over here, okay? Any other thing you guys want to throw at us? Like k, f, m, g, and k. Lovely. Oh, we already said k over there. Okay, calm down, Kevin. Given that k, you're the teacher, you got to be an example. Can't be doing this learners can't be doing this in a test. Given that k is equal to f of that, determine the value of m such that g is a tangent. Okay, it's actually not too bad. All right, so I know that it's a tangent, and I know that this graph over here, whether I don't even know what m is, but I know that m is just a number. So this is going to be an x square, so I know that this is a parabola. Okay, so let's say you've got a parabola, boom. And let's say you've got a tangent, boom. How many times do they intercept? Twice? 0 or 1. It's only going to be 1. A tangent cannot touch a parabola twice because then it's not a tangent anymore. And it can't touch a tangent 0 times because then it can't touch the parabola 0 times because then it's not a tangent. So there has to be one solution. Remember that. That's important. A tangent, parabola, one place. Okay, but I know that the parabola and the tangent touch. If I asked you, where does this parabola and where does this straight line intersect, for example, and I gave you this one's equation and I gave you this one's equation, and I asked you to find where they intersect, how would you do that? You would make them equal. So that's what we're going to do first. We're going to make the equation of k, which is this, and we want it to be a tangent to g. So we're going to make g's equation equal to that, just like we would normally do when we have to find out where two things intersect. So we're going to make k's equation equal to g's equation. Okay, so that's going to be negative x squared minus 2mx minus m squared plus 4x plus 4m plus 5. Next time, why didn't they just give us the whole alphabet? Jeepers. Okay, and so g's equation is 2x plus 2. All right, matey. Okay, so now what we're going to do is I want you to now, don't worry about the fact that we have two unknowns. We've got x's and m's. What we're going to do is just simplify this, take everything to the left and try and make it equal to 0 on the other side. So I'm going to put all the x squares together. Then I'm going to put all the x's together. So it's going to be minus 2mx plus 4x minus 2x, which is this one over here. Now I'm going to put all the other stuff together. That would be like the constants. So we've already used this, we've already used this, we haven't used this, so that's going to be, and we've already used that, and we've already used that. So minus m squared plus 4m plus 5 minus 2. I want it in that format of all the x's, all the x squares, then the x's, and then the constant. We'll see where we're going with this. It actually wraps up quite nicely. Okay, so what we're now going to do is we're now going to go and simplify these two. 4x minus 2x is just going to be 2x, sorry. Looking to see if you're awake. And then minus m squared plus 4m. Are you awake, by the way? Or are you chilling now at like 3:30 in the morning and you've got your exam coming in 2 hours? Wake up, wake up, wake up. I'm that annoying friend right now. Okay, and then 5 minus 2. Okay, 5 minus 2 is 3. Now you can see why I'm a maths teacher. Now, yes, we have two unknowns, okay? However, what did we say earlier? A tangent touches a parabola in exactly one place. So when we eventually do solve this equation, how many answers would we want to get? Would we want 0 answers? No, because then that would mean that the tangent and the parabola never touch because there would be a no solution. Would we want 2 answers? No, because then we're going to get a scenario where the lines intersect the parabola twice. Then it's no longer a tangent, but we only want one solution. Now I want you to think about nature of roots, and I want you to specifically think about the discriminant, this part over here. We've learned that when that part over there, stick with me guys, stick with me, I promise you it's going to make sense. When that part over there is negative, smaller than 0, let's write here, negative, then it means no. That means the parabola and the line do not intersect. That's not the scenario that we would like. That's not the scenario that we are going for. Other scenario is we've learned that if this bad boy over here is equal to 0, then what we end up getting is 2 equal solutions, and that is exactly what we want. That is like having x equals to 3 or x equals to 3. I know it looks like we have 2 answers, but they are exactly the same, so we call that one solution, and that would make it a tangent, and that is what they want. So all we're going to do now is realize that we want this thing here to be equal to 0 because that means only one solution. So we're going to say b squared minus 4ac must be equal to 0. Now remember that a is whatever's in front of the x squared. B is whatever in front of the x. So we need to first go fix this up a little bit. And then c is all the other stuff. Okay, so we need to go fix that up quickly. So we're going to have minus x squared. Now to fix this up over here, you're just going to say plus x. And then you're going to take out the minus 2m and the plus 2. Okay, minus 2m plus 2, and then the minus m squared plus 4m plus 3, that's just the leftovers. So this part over here is going to be C, this part over here is going to be B, and this part over here is going to be A. And so now we're going to go, now this is pretty high level stuff, the rest is fairly easy, but understanding this part here, pretty decent, okay? It's actually quite good. So, right, so now we're going to say B, which is minus 2m plus 2, and we're going to square that. And then A is minus 1, and then C is all this other stuff. So now we're just going to go solve this thing here. So this thing here, you're going to put a double bracket. So you're going to end up with negative 2m plus 2, negative 2m plus 2. And then with this part over here, we can actually just turn that into plus 4, and then minus m squared plus 4m plus 3. Okay, let's go now. So now we're going to go 4m squared, take away 4m, take away 4m, add 4, then take away 4m squared. Haha, that is beautiful. Plus 16m plus 12 equals 0. Let's just write that a bit better. Okay, so 4m squared minus 4m squared, they cancel. Thank goodness, I did not feel like doing another trinomial. Okay, so minus 4m plus 16m, that's going to be 8. And then positive 4 add 12 is, and then if we take the side, m is negative 2. Awesome. That's a good question. Mary's grandparents deposited 5,000 Rand into a savings account on the day that she was born. The account pays interest at a rate of that, compounded quarterly. Calculate the accumulated amount. All right. So if you are a grade 12, don't use present or future value formulas for this. This is a grade 11 question. As a grade 12, we often get very stuck and we think, we get confused and we think, oh, everything is future value, present value. You only use future value and present value if the person is making the payments regularly, like every month or every quarter. These grandparents, they deposited 5,000 Rand into a savings account on the day she was born. They don't say that they carry on paying, so it's a once-off payment. So we're just going to use the grade 11 formula. So it's pretty straightforward. P is just the amount that was deposited. Interest rate is 6.8%. So there's various ways you can write this. I say 0.068. I get that by saying 6.8 divided by 100. Okay. And then they say it's compounded quarterly. How many quarters are there in a year? 4. Don't say 3. I know some people think, because quarterly is a bit weird because there are 4 quarters in a year, but that means every 3 months you make a payment. So some learners, they think that you should put a 3 at the bottom here, but it's a 4. And then, okay, so she was born and then she's going to be 16. So that's going to be 16 years. It's going to be 16 times by 4. That's what you would put over here. You can say 16 times 4, or you can just say 64. And that's it, guys. We just go type it all in now. And so Mary will have 14,706 Rand and 56 cents on her 16th birthday. After 4 years, the value of a printer was half the original value. Determine the rate at which the value depreciated if it depreciated according to the straight line method. Okay, so there's a few things we need to unpack here. Number one is whenever you buy something, right? Maybe let's say your parents who have a car. What happens to the value of a car over time? Well, it goes down. We call that depreciation. Okay, here we can see that they said the printer depreciated. They said that the value of the printer, they don't tell us the starting amount, the ending amount, but they tell us that the value of the printer is the original value. So what we can do is we can say, let the original value equal X. You can say whatever you want. You could say 2X. Therefore, the value after 4 years will be a half of that. So the value after 4 years will be a half of X, because they said after 4 years, the value of the printer will be half the original value. Now, it says determine the rate. So that means the percentage. That's what we're trying to find, at which the value of the printer depreciated. Now, here you got to be careful. They said the straight line method. In life, things can, okay, let me give you a quick little example. When we're talking about investing, so that's not the same as depreciation. I'm talking about investing. Your money can grow, straight line method like that, which is where you would use this formula over here, which is like the simple interest, right? Or your money can grow compounded, and that's where we used to use the compound formula. Now, when we are talking about depreciation, because these are both investments, because the value of your money goes up. But when we are talking about depreciation, you get the same thing. Your item, like your car, can either depreciate like a straight line. So that would be called the straight line method. I wonder why they call it the straight line method. I've been trying to figure that one out for a long time. I don't get it. Obviously, it's because it's a straight line, guys. And then the other way it can depreciate is called the reducing balance method, which is when it does it like a curve. That's called the reducing method. So this one uses this formula. So because it's depreciating, instead of putting a plus, we put a minus. And then this one just uses the compound formula, but instead of using a plus, we use a minus. That's it, okay? That's the scenarios we deal with. So in this question, obviously it's a depreciation question. So we're not going to be looking at, it's definitely one of these two. And then they said it's the straight line method. Okay. So I don't know how you're going to read that and remember that that's the one that uses the straight line. But yeah, whatever works for you. Okay. Obviously I'm making a joke. It's the straight line method, guys. So it's this one over here. So we're going to use this formula. We're going to say A equals P1 minus I N. And for those of you that have maybe just need a bit of a recap, P is always the original, A is always the final, because some learners think that A must always be larger than P. It's not true. When you are dealing with depreciation, your A value will always be less than P because the item is depreciating. I is your interest rate, and then N is your time. So let's quickly write that formula down again. 1 minus I N. Right, so we know that A, the value, the final value is a half x of x. We know that the original value is x. Okay, and then 1 minus. Now I is what we are trying to calculate, but they did say that it is oh no, they didn't say anything funny. Okay, and then how long? 4 years. So time is going to be 4 years. So there we go. So these two are being multiplied together. So I'm just going to make it 4i. There we go. It's like me with my glasses. 4 eyes. Come on. Right. So now what happens with these type of questions is that the x's, you can see that they are the same on both sides. So you can actually cancel them. And so we just go boom. And that's why it doesn't matter what you chose in the beginning here. The ratio of these two is always going to end up being a half. Whether you chose 2x and 4x or 6x and 3x, it doesn't really matter. Okay, so we end up with a half on the left. On the right, we just have 1 minus 4i. We don't need the bracket anymore because the bracket was simply keeping this out, but that's no longer there. So now it's just a case of solving for I. So I'm going to take the 4i over to the left, and I'm going to take that over to the right. And so we end up with a half. And now we're just going to divide by 4. So we're going to get I equals to 1 over 2 divided by 4. And so I would end up being 1 over 8. But now remember, we have to multiply by 100 to get it back into a percentage. And so we're going to end up with 12,5. Right, now I've done questions in the past where they used the same name over here. And I've been teased by people when I say Shepo. Guys, a white person, for me personally, it's very difficult to be like, Shepo, because I'd never get it right. Or maybe that was right, but I feel really cringy because I really have to try hard to do it like Shepo. And I don't want to say Chepo, like very Afrikaans teachers. Hello everyone, come sit down, we're going to do this question. Okay, so Chepo. No, that makes me cringe like you cannot believe. So I just sort of like ignore the T and I'm just like Shepo. But I've had people comment and they're like Shepo and then they put like crying face emoji. So fine, if you guys want me to do it, fine. Shepo was granted a loan of 100,000 Rand on 1 March 2020. Okay, I'm actually not reading. I'm reading, but I'm not focusing. Okay, so granted a loan of 100,000 Rand on 1 March 2022 at an interest rate of 13.5% compound monthly. Okay, Shepo agreed to repay the loan over 5 years in monthly installments starting on 1 April 2022. Calculate the total interest he'll pay over the 5 years. Very easy, that first question. There's nothing funny here. Remember, when someone goes to get a loan, what have I taught you guys? When are they supposed to make their first repayment if everything is normal? 1 month later. So if the person opens the account on 1 March and they make their first payment on 1 April, all's good. There's nothing funny here. Now, calculate the total interest. Well, check this out, guys. How much did this person, how much did Tepo go and get from the, how much did he go and borrow from the bank? He borrowed 100,000 Rand. Picture that. I want you to visualize that. He walks into the bank one day and they give him 100,000 Rand, or they deposit that into his bank account, okay? If there was no such thing as interest and life was just so simple, if you borrow 100,000 Rand, you have to pay back 100,000 Rand, well, that would be really easy. We would just say, he's going to pay back 100,000 Rand. But obviously that's not the way it works in real life. That's the way banks need to make money. They're borrowing you money, so when you pay it back, you're going to pay back more. There's no real, we don't need to look at the interest rates or anything like this here. They told us what his monthly payment is, and this question is only 2 marks. So if this guy's going to pay back that amount for 5 years, every single month, how much money will he pay back to the bank? Well, we can say 2,300.98 multiplied by 5 multiplied by 12. And that would give us, and it's definitely going to be more than 100,000 because otherwise he's paying back the bank less than what he borrowed. And that would be weird. Here we go. He paid back 138,058.80. So he borrowed 100,000. That is how much he paid back. So how much interest did they add? Well, you can just minus those two numbers, can't you? 058,80 minus 100,000, and that means he paid an interest of 38,000.80. So let's just talk about this, how it works in real life. So imagine you need 100,000 Rand urgently. Maybe you need to buy something pretty urgent. So the bank will give you 100,000 Rand. And for the next 5 years, you're going to pay that amount back every month. Now, a lot of you would look at that and you think, that's not too bad. I mean, if I'm working or whatever, we can afford that. But what you must remember is that you're actually ending up giving the bank that amount back. It doesn't feel so bad in the moment, but just keep that in mind, okay? That you actually just spent 38,000 Rand just because you borrowed from the bank instead of just using your 100,000 Rand that you might have been able to save up. So that's the way banks make money, but it does make life a lot easier, especially when you are earlier in your career and you're still busy building up your finances. It might take too long to wait for 100,000 Rand, so it's easier to just go and pay back that amount each month. Okay, so there's pros and cons to it, especially if you're a young person and you're wanting to start a business or something, or you need a car to be able to do your business, then it makes sense that you will go to the bank and ask them for 100,000 Rand and then pay them back that amount each month, because without that car, you wouldn't be able to make money. So it does make sense sometimes when you need to borrow, but what doesn't make sense is if you go borrow 100,000 Rand from the bank so you can buy PlayStations and 55 games and PlayStation controllers. Because now, what's the point? Unless you become a gamer and you make a lot of money from it, it makes no point. Okay, Kev, talking too much. Moving on to this question now. It says that Tepo paid 22,300.98, which was his monthly installment, and he paid an additional 20,000. Okay, I'll explain that to you guys now. On the 1st of March 2024, he continues to pay the original monthly installment thereafter. Okay, so this is a bit of a mind, if you know what I mean, a mind F-U-C-K, when you read this, but I'm going to do my best to break it down nicely what's actually happening here. Okay, so let's just make sure we understand the whole picture. We have a guy, Repo, who went and got a loan from the bank one day on 100,000 on 1 March 2022. The bank said, perfect. You pay us back this much every month, and you're going to do that for 5 years. Fine. He could have left it that way. However, Tepo he's a thinker. He's an interesting character. So what he does is he likes to switch it up a little bit. Was on 1 March 2024, he paid his original monthly installment, which is 2,300.98. And then he walks into the bank one day, and maybe the person behind the till, maybe she was a beautiful lady, and he wanted to flex a little bit that business is going well, and he can afford to pay back a little bit more this month. So he whips out 20,000 Rand, slams it on the table and says, add that to my loan account. So this is something that people actually do in real life. They take out a loan originally, like 100,000 Rand. But then maybe a year or two later, maybe their life situation is so much better, or their businesses are doing so well, that they decide they have extra money available, so they decide they want to pay back more into the loan. Because the more you can pay back into the loan, then it ends up causing you to pay less interest over time. So you know how we calculated the interest here, and it was like 38,000 Rand? But that was only if he kept paying this much for 5 years. However, because he now puts an extra 20,000 Rand immediately, it's going to end up causing this to become a lot lower. So he's actually saving money by paying back the loan faster, okay? So what they want to know now, knowing that he's just flexed his wealth and he's put down 20,000 Rand, how many months earlier will he be able to repay the loan? Because it's no longer going to take 5 years. Maybe it's going to take a little bit less time now because he took that 20,000 Rand and he just paid it immediately. Okay, so how do we handle a question like this? For some of you, you might be thinking, Kev, can't we just take this a number and then divide it by that, and then we can see how many months that is and then just subtract? Not right. In an ideal world, yes, that makes sense. But because of this thing called interest and time, that doesn't work. And bro, you're going to do that for 7 marks. Not going to happen. So what are we going to do? What I want you to do, completely forget about this 20,000 Rand right now. And I want you to go work out or tell me how much does he owe the bank on 1 March 2024. So what OB outstanding balance on 1 March 2024? And I want you to ignore 20,000 Rand for now. Of course, we're going to include it, but we're going to ignore it for now. Okay, so I want you to tell me, what does he still owe the bank on 1 March 2024? You can use outstanding balance in different ways. Some learners like to use this method where you work out your loan value minus the future value. Okay, so some of you like to use that method. Okay, you can. And then other learners, including myself, we like to use the present value formula. So we just use the present value formula because then it's just one step. But some learners love this method. So do whatever you want, but I want you to go work out the outstanding balance for me on the 1st of March 2024. Okay. So I'm going to use my method, my present value method, but you don't have to. I'm not saying one is better than the other. I think they're both pretty cool. So we know that this formula goes like this, and we're totally forgetting about that 20,000 for now. So what we're going to go and do is we're just going to say, okay, so we still know that he's paying 2,300.98, and we know that the interest rate is, and we know because I got it over there. And I know that when I use this formula, then I know that the number of, it's the number of payments that still have to be made. So we know that in 5 years, if you're paying monthly, that would be a total of 60 payments. But we know that he opened the account on 1 March 2022, and now we are at 1 March 2024. So 2 years have gone by. So 12 times 2 is 24. So he's already done 24 payments. He is supposed to do 60. So how many payments does he still have to make? You could say 60 minus 24, which is 36. But Kevin, what about this part of a year? Guys, forget about that for now. Completely forget about the 20,000. We will get to that. Trust me. I'm working on something here. Okay, so we're just going to go put 36 here. If you're using the other method for calculating outstanding balance, which is using the future value and the loan amount, then you would be using a 24. You wouldn't be using a 36 because that method uses the number of payments that have already happened. Let's close this bracket. Let's go work 0.135 over 12. Okay, if you go type that all on the calculator, we end up with 67,804.94. So what does that mean, guys? It means that on the 1st of March 2024, if we forget about this, if Tepo had to walk into the bank and say, yo, how much do I still owe on my loan? They would say, your outstanding balance is this amount over here. Now, the way that a loan works is if Tepo now has to walk in there and say, listen, I've got 20,000 Rand here and I want to pay that towards my loan. What the bank does is they take that 20,000 Rand and they simply say, your outstanding balance, we will subtract 20,000. So your outstanding balance is now 47,804.94. If you're using the other method of calculating outstanding balance, you might get a slightly different answer, okay? So now you see how we've used the 20,000 Rand. I told you guys, don't stress, we're going to use it. So now we have a brand new outstanding balance. So that is the new present value of his loan. That is what the value of his loan is on the 1st of March 2024. So what we now go and do is we just go use this formula and we use the new present value. Oh, that sounded weird. The new present value, yeah, that's what it is. We know that the payment doesn't change because it says he's still going to use the original monthly installment. The interest rate doesn't change, but now we can go calculate the new end value of how many payments it's going to take to pay off the new loan value. So we can go use that formula again and we can say 47,804.94 equals to the original monthly installment, which was over there, and then 1 minus the interest rate doesn't change, it's still 135%, but we now don't know the brand new number of payments that still need to be made. When we get this answer, that's not the final answer. I'm just saying there's an extra little catch at the end, okay? And then 0.135 over 12. Right, now some learners get confused here. Remember that this part here is 1 unit, so you can't do anything with that right now. What we can do though is we can take this and this to the other side. So this one you're going to end up dividing, and then this one you're going to end up multiplying over there. If you had to go and do all of that, just to save space, I'm just going to go straight to the answer. But don't round off, because the fact is we're going to have to use logs. And logs are extremely sensitive to rounding off. If you round off even just a little bit, it can change your answer quite dramatically. And so you're going to end up with 0,233728922. Let me just double check. It's 2272892. Okay. And then on the right, if you want, you can type that on your calculator. Okay. So on the right, we now have 1 minus. I don't need brackets. These brackets anymore, because those brackets were only keeping this and this out, but we've gotten rid of those now. Okay, now this part over here, if you type it in on the calculator, you get 809 over 800. Okay, what we now do, this is 1 unit. Don't like that it's negative, so I take this whole unit to the left so it can become positive, and then I bring this to the right so it can join this 1 over here. So you end up getting 809 over 800. The n doesn't change its sign, and then I take this and then you get 809 over 800 equals to, don't round off because we're busy with logs. Well, we're going to use logs now, 27107. With logs, what I like to do is remember that this is called the base because that's the exponent. Now here's a little thing I want you to remember. I've started recently telling learners this. The base stays. To work out logs now, with logs, you're always trying to calculate the exponent. So you're going to say minus n equals to log. Now the base stays the base. So the base always goes down here at the bottom. So that's still going to be 809 over 800. And then the other part is going to be the 0.76627107.8. Now some learners, they struggle to write the log like this. They don't know which log to use on the calculator because on a Casio there are 2 log buttons. You want to use the log button that is immediately below the on button on your calculator. Okay, so if you had to go type that log in on your calculator, you get negative 23.80. You can round off now, that's fine. And so if we divide both sides by that, we get 23.8. Some learners are going to stop there and they're going to think, okay, they finished with the question. We must understand that this actually means 24 payments because you can't make 23.8 payments. But now some learners think that that's now the answer, but it's not. Because remember when I asked you to work out the outstanding balance over here, when we ignored that, how many payments did we still have to make at that moment in time? Well, at that moment in time, we still had 36 payments that still needed to be made. Remember? Because we had a total of 60 months, and at this moment, we had already made 24 payments. So we still had 36 payments. What we've just worked out now is that we still have 24 payments. So how many months earlier will he repay the loan? Well, instead of making 36 months, he's now only going to have to do 24 monthly payments. So if you say 36 minus 24, that is 12. And that is the answer, months earlier. When they ask you to determine d over dx, that's just another way of asking for the first derivative. And so we can just make that equal to, now we don't need to do any modifications. This can be, we can take the derivative immediately. So when we look at 3x, remember that there is a 1 there. So you multiply the 1 and the 3 together, so that'll give us 3. And then you subtract 1 from there, so it'll become x to the 0, which will just fall away. And then for this part, you are going to multiply the 2 and the 5 together, so it becomes 10. And then you're going to subtract 1 from there, which will just be a 1. But you don't have to write it if it's a 1. And so the final answer would be 3 minus. Here they want us to find the first derivative if this is the original expression. Okay, and it's for 4 marks. Now, we can't take the first derivative at the moment. We still need to go fix up g of x a little bit. We can't have x's at the bottom. So the first thing we're going to do is we're going to take that to the top. So it'll become x minus 2. And then for this part over here, you don't want to have a square root. You always want to write it without the square root. So the way you do that is you always take the inside exponent over the outside number. Okay, now we can go take the first derivative. So we can now write it as the little line like that. And so the way it works is you take this number and you multiply it with that number. And then what do we do with this minus 2? We have to subtract 1. So it'll become minus 3. Then moving on to this part, this number here is going to multiply with the number in the front. It'll just become negative 7 over 3. And then what are we supposed to do with this again? We need to subtract 1. And so that'll become 4 over, and there we go. Back in the day, like a couple years ago, they wanted us to please write the answers with positive exponents, but nowadays we are allowed to leave it like this, and so that would be your final answer. Determine the equation of the tangent to the following graph at the place where x is 2. You cannot get an easier question than this, guys. All we need to know is that when you have any kind of graph, if you have a tangent, and at the place where the tangent touches the graph, if I had to zoom in, it would look like this. It would look like that. Now, at that exact place where they touch each other, okay? If I had to zoom in even more, pretend that I've zoomed in, actually going to look like that. If you had to zoom into the place exactly where they touch, yes, on the left it's going to go down and on the right it's going to go down. But at the place where they touch, can you see that their gradients are exactly the same? You can see that they're both going in that direction like that. So what we know is that at the place where a tangent touches a curve, the gradients are the same. The gradients. So they want us to find the equation of a tangent, now of this tangent. Now a tangent is a straight line, so y equals to mx plus c. M is the gradient. Now we've just seen that at the place where a tangent touches a curve, the gradients are the same. So if we can find the gradient of this curve, then we also have the gradient of the tangent. Now the question is, how do we find the gradient of a curve? Well, that's where calculus comes in, and specifically the first derivative. So we take the first derivative of this, which would give us 3x squared minus 8x plus 2. Now, so many learners, they just want to always say equals 0. We're not going to say equals to 0, because if you say equals to 0, then you are saying that the gradient is 0. But who says it was? But Kevin, why do we often use equal to 0? Yes, that is because very often we are looking for minimums and maximums. And at those kind of places, at minimums and maximums, like there and there, then we can see, look at the line. Can you see that the gradient is 0? In this question, no one says the gradient is 0. So then what do? Well, what we do is we go fill in the x value of 2. And we see what is the gradient at the place where x is 2. So you can go fill that all in now. You get negative 2. So that means that the gradient of the graph, so the gradient of the graph, x equals to 2, is minus 2. So therefore, the gradient of the tangent is, remember that that's going to be the same as the gradient of the graph, so that'll also be minus 2. So now we know this value. We can now say that y is equal to minus 2x plus e. By the way, you don't have to go write all of these notes in the exam. These are just study notes that I'm helping you guys with. Now to find c, how would you normally do that? Well, you would need to plug in an x and a y. We only have an x. However, can't we just take that x, plug it into this equation to get the y value at that point? Because remember, where a graph and a tangent touch each other, they're going to be sharing the same x and y point. So if we know the x value on this curve, we can then go plug that x value into this equation and get the y. Now some of you might be like, but Kevin, didn't we do that over here? No. Here we plugged in the 2, but we didn't plug it into the original equation. We plugged it into the first derivative equation. So this thing here gives us the gradient, whereas when you plug it into this equation, getting the y value. Two different things. Okay, so we'll go plug in the x value, and let's see what the y value. Y value is -1. Okay, so what we've just worked out now is that at the place where they are in contact, the x value is 2, and the y value is -1. So that is also going to be a point on the tangent itself, so we can use that over here now. And so we could say that the y value is -1, x value is 2, and if you had to work out c, you would eventually get 3. E would eventually equal. So now we have the equation of the tangent as y equals to -2x. Given that we have f of x equals to -6x squared, determine the first derivative using first principles for 5 marks. So what I always tell learners, go calculate this quickly using the FOST method, the normal first derivative method. Well, that would easily just give you -12x, because you just multiply the 2 over there, and then you subtract 1, and that would be the answer. So when you get to the end of this question, if you don't have that as your answer, you have made a mistake. Let's go do this now for 5 marks. So we know that the first principle formula goes like this. Okay, we got to say limit as h goes to 0, f of x plus h minus f of x all over h. Okay, so I'm going to start with over here. So that's going to give, what that means is that whenever you see x, you're going to put a bracket and you're going to replace it with x plus h. So you're taking this equation, and wherever you see an x, you're replacing it with x plus h. Matches with, next thing we see is a minus, and then we see a f of x, which is the original equation. But I always tell students, it's the number one reason there's mistakes in this first principle questions is we must use a bracket for the second part. Now we just want to go simplify, so we have to keep writing limit as h goes to 0. Now some mistake that learners make is they just put the 2 in the x and the y. Not correct. You have to use a double bracket. You have to go like that, and then here we get plus. If you ended up with a minus over here, it's because you didn't use a bracket, over h. Okay, now we keep writing limit as h goes to 0. Now I'm going to leave the -6 as it is, and then I'm going to multiply the brackets out. It will eventually become 2xh, xh plus another xh, so it'll become 2xh, and then this part over here. Okay, now we're just going to go multiply that 6 in, so -6x squared minus 12xh minus 6h squared plus 6x squared over h. Now, if you've watched my first principle videos before, you would know what I'm about to say. At this point, everything that doesn't have an h should cancel. So you see this one and this one, they cancel. That's good. Everything else has an h, so they won't cancel out. Okay, and so now we keep going. Limit h goes to 0. Now, what I always tell learners to do here, even if you can take more of a common factor out, just take the h out. Just take the h out when you're doing these first principle questions. So you're going to be left with -12x minus 6h. And that's all over h. The reason I say that is all that we actually want is just these h's to cancel. Because now we can actually, because now what we have left is we just have -12x minus 6h left over. And now we can actually, we can let the h go to 0 now. The only reason we couldn't let the h go to 0 earlier was that we had a h in the denominator, and that would be undefined. Now that we've cancelled that h out, we no longer need to worry about that, and so we can now plug the h as a 0. So because of that, you don't have to write the limit as h goes to 0, and you end up with -12x minus 0, and that's just going to be minus 12x. And that's exactly what we said the answer was supposed to be earlier when we did the FOST method. This question says, write down how you would restrict the domain of f such that the inverse is a function. Very easy. What you must understand is that this over here is a parabola. It's got a negative in the front, so it's upside down. It has no plus over here or minus, and it has nothing in the brackets with the x. So it has not been moved left or right, and it has not been moved up or down. So it's literally at the origin like that. And now that is what this graph looks like. If you then had to go find the inverse of that, it would end up doing this. And we know that that is not a function. Why? Because if I had to draw a vertical line, see how it cuts more than once. Notice how it cuts more than once. So the only way that we will be able to make this thing a function is if we either have it like that, because both of those are functions. If you draw a vertical line, let's do it. If you draw a vertical line, it only cuts once. So how should we cut this part over here up so that when you take the inverse, well, you're either going to get rid of, then you have that, you're rather going to keep it. So the point is, you can't have both sides. Because if you have both sides, then when you take the inverse, you're going to have both sides as well. But if we can just have one side, then it works nicely when we take the inverse. So how would we restrict the domain? Well, the domain is all of the x values. So you can see over here, we have all of the x values. X is an element of R. But if we want to be able to restrict it to either that over there, then if it was like that, x would only be bigger than 0. If you prefer, you could write it as interval notation. You could leave your answer just like that, or if you use interval notation like that, or you could also write it as, you could also do it this way rather. You could say that x must be smaller than or equal to 0. If you do interval notation, that would be minus infinity up to 0. You don't have to put both answers, you only have to choose this one or this one. And also, if you prefer set builder notation, you only have to leave it like that. Whereas if you like interval notation, then you can use that one. You never have to give both of them. Now, this question for 3 marks. Determine the equation of the inverse being smaller than or equal to 0. Okay, so this part will only come in towards the end, but for now, let's just go find the inverse. So we know, so with inverses, we know that the first step, we're just going to go write it as y equals to minus 6x squared. First step, switch x and y's around, then get the y alone again. So what I would do is I would divide by minus 6, so you'd end up with x over minus 6. Then I would take a square root on both sides, and I would say plus minus for now, but we are going to have to make a little change. So yeah, I don't really want to have the minus 6 written like that. So we can actually just, you can leave it like that, but I'm just going to put the negative there. Now, we have to think about this carefully. So we can't leave it as plus minus in this scenario because they've asked us for the following. So they want the inverse. So remember, the original graph looks like this, and we said that the normal inverse would then go like that. But now you got to think of it as the top half and the bottom half. Now they said that they want the inverse to be smaller than or equal to 0. What that means is below. So if this is the x-axis, they want the part that is below. So they want this part here. So what are the y values in this part of a graph? Are those y values negative or positive? They're negative. So here we're saying that the y values are going to be positive or negative. We only want the y values to be negative. So we're going to take out that one, and then we're just going to have that. And we know that this part inside here will never be negative because you can never have a negative inside a square root. So we know that this part here is always going to be 0 or positive. So then by having a negative in the front, it's only ever going to allow this whole thing to be negative. And that's what they want. They want the y values to be negative or 0. It can also be 0 because they said here it can also include 0. So you want the negative to be left over here. A and B are the turning points on the graph, and C is the y-intercept. First question, for which value of x is the graph decreasing? You can actually just see that on the graph. Here we can see the graph is increasing. Then we can see over here, get a different color. Here it's decreasing, it's going downwards. And then here it's going up. Have you ever wondered, but Kevin, that doesn't make any sense, because if I go this way, then I could say that that is decreasing and that is decreasing, and then that one would be increasing. Good question. Always has to be from left. So when moving from left to right, that is increasing, and then that. So where is the graph decreasing? Well, it's between A and B. So it's from the x value of 1 to the x value of 5 over 2. You can either write it, if you prefer interval notation, you could say that it's going from 1 to 5 over 2. Now, if you prefer set builder notation, then you would say that. Now, some of you are like, Kev, why don't we include the 1 and we include the 5 over 2? Well, that is because at those exact moments, the graph is not decreasing. At those exact points, the graph is flat. So the graph is neither increasing or decreasing. So if you had to include these values, it wouldn't be correct, because then you are saying that at the 1 and at the 5 over 2, the graph is also decreasing, but it's not. Okay, so we've done that one. Now, write down the x-intercept of the first derivative of f. Okay, so listen carefully, guys. I'll try and make this easy for you. We know that for any graph, how do we find the x-intercept? For any graph, to find x-intercept, you make the y value, you make the y 0. But what do we mean by y? Well, you make the, whatever the f of x part is, you make that equal to 0. But now imagine you had a graph, and that graph was the first derivative. So you have some equation. Okay, let's say we have some equation. Then all that you do is, if you wanted to know the x-intercepts on this graph, well, then you would just make that part 0, right? So whenever we want to find the x-intercept of any equation or graph, you make this part 0, the part that is in the place of y. So to find the x-intercept of this graph or this function, then you just make the first derivative 0. Okay, but so we make 0. But now what is this? This stands for gradient. So where on the graph is the gradient 0? Well, that would be at the turning points themselves. And so what are the x values at those points? 1 and 5 over 2. So those would be the x-intercepts of this function. Okay, I hope that makes sense. So you'd say x equals to 1 or x equals 5 over 2. But we should probably, because it's the intercepts, we should give the exact 1 and 0, and then 5 and 2. 5 over 2 and 0. This question says, for which values of x is the graph concave up? Well, we know that the shape concave up, if you're feeling happy and you're feeling upbeat about life, then you look like a smiley face. That means concave up. If you're feeling down, that's concave down. So where do you see more of this kind of shape on the graph? Is it this first part over here? You see how it's bending down like that? No, that's a sad face. It's more over here. You can see that's where the smiley face begins to happen. So where does the smiley face begin? Well, it's going to be exactly in between these 2 points. It's going to be over there, and we call that our inflection. So you can literally just go and take the midpoint of those 2 values. So you can just say 1 plus 5 over 2 divided by 2. That'll give us 7 over 4. So let's just see, for which values will it be concave up? Okay, so we know that this is 7 over 4. Okay, so that's where it starts, the x value of 7 over 4. And we said that concave up is this part over here. So it's going to be everything to the right of 7 over 4. You could say x must be bigger than 7 over 4. Or if you prefer interval notation, you could say 7, we're not including 7 over 4 up to. Don't include the 7 over 4, because at 7 over 4, it's not concave up or concave down. It's the inflection point where it's changing from the 1. Okay, this last one says, determine the value of k for which this expression will have 3 positive x-intercepts. Okay, so don't worry about the word intercepts for now. Just think of x values. Let's say, to get your mind on the right track of how these questions work, let's say I drew a horizontal line over here. How many times does it cut the graph? Once. Would this x value be positive or negative? Well, that would be a negative x value. Okay, so this is one negative value. I want you to now think, where could you draw a horizontal line so that it has 3 positive x values? So maybe you try draw one over here. Well, there it only cuts 1, so that's going to be 1 positive x value. Where could we get 3 positive x values? Well, that would be if you drew a horizontal line anywhere between the 2 turning points. So maybe there. See how many times you got there? 1, 2, 3, and they're all positive. Or maybe over there, or maybe over there. Can you see that any way that you draw a horizontal line between those two turning points, you get 3 positive x values? Okay, now all that we then need to do is think about how could we move this graph so that these areas over here that we spoke about would end up being on the x-axis. Let me explain. If we move the graph down by 9 units, then this point would be over here, and then your graph would be something like, it would turn over there and then do something like that. This is if we move the graph down by 9 units, okay? So, and then if we move the graph down by 8 units, then this point would be over here, and you would get something like, so those are the two extremes. What would happen if we move it down somewhere in between that? So like, let's say we move the graph down 8.5 units. Well, then it would go in between. It would be like there, and then this point would be over there, and then you would have a graph that does something like that. And now you can see that you're getting the perfect 1, 3, okay? So if you move this graph down by somewhere between 8 or 9 units, then it's going to have 3 x-intercepts. Okay, so if y is equal to f of x plus k, this part here moves a graph up or down depending if it's positive or negative. So we definitely want this to be negative. We want it to be something like 8.5, for example, anywhere between 8 and 9. So we want the k value to be anywhere between -9 and -8. It must be some number between those two. Okay, so we can then say that k must be bigger than -9, but smaller than -8. Remember that -8 is bigger than -9. So that is the answer. We want k to be any number between -9 and -8. So like maybe -8.5, because then your equation would say f of x minus 8.5, which means you're moving the graph down by 8.5 units, and that's where you're going to get 3 x-intercepts, for example. But maybe it was like 8.4, 8.3, 8.1, 8.9, it doesn't matter. If you prefer interval notation, you would go between -9 and -8. A cyclist rode from a town P and stopped at town T. Okay, so a cyclist goes from town P, town T, okay? The speed at which the cyclist rode is represented by the following equation. Now, first things first, I don't want you to look at that S and think that that means speed. It doesn't, okay? They could have used totally different letters. That S is actually a notation to represent position, so it's something totally different. So it says that the speed is given by this equation. So completely don't worry about that line over there. That is the equation for speed, okay? So speed is going to be that equation over there, plus 18t. Now it says, calculate the maximum. So when you calculate maximum of anything, you have to take the first derivative. So you have to take the first derivative of the speed equation. But now what's confusing is they already have a first derivative symbol. Ignore that. Just carry on as per normal. So go take the derivative of this. So you're going to have to put another little line there. So it feels like we're taking the second derivative, but it's still just the first derivative of this equation. And so you're going to go take that, and that's going to give you that. We know that to find a maximum or a minimum, we then make that equal to 0. You see, normally we would say to find the maximum, make the first derivative equal to 0. But they started us on the first derivative equation, and that's what makes this question a little bit weird and a little bit annoying from my perspective, because I could see how this can cause a bit of issues. Okay, so we took the first derivative and we got, now you're just going to go solve for t, should get t as 3. So that means at 3 hours, the cyclist has reached the maximum speed. So what would that maximum speed be? Well, now you go plug it back into the original equation for the speed, and so you're going to end up with minus 3 times 3, and you're going to end up with 27 kilometers per hour. Okay, so that is the maximum speed that the cyclist reaches. Calculate the distance between P and T. Okay, so this is quite interesting because in grade 12 pure maths, We've gone over this section in calculus, and one thing you must remember is that it always goes like this. Distance then goes to speed, and then that goes to acceleration. And to go from the distance to the speed to the acceleration, for example, let's say I gave you an equation that said that the distance is equal to 10t cubed plus 6t squared. Then to go to speed, this is just an example, hey guys, that I'm showing you guys now. To get the speed, you would take the first derivative of this equation, which would give you that. And then to get acceleration, you would then take the derivative again, and you would get that. So to go from distance to speed to acceleration, you just take the derivative each time, and it must go in that order. There's a whole scientific reason as to why it goes like that. Now the thing with this question is they've already given us the speed, so they've given us this one, for example, and now we are somehow expected to be able to go backwards. I'm going to show you it's not actually too bad. So let's try figure out what the original equation for the distance must have been if this is the formula that they gave us for the speed. So we have to somehow work backwards now. Okay, I actually shouldn't have erased that. I wanted to show you guys something. Okay, I'm just going to use different formulas now. Maybe it's the same. I can't remember what I used, but whatever. Okay, so if that was the original equation, for example, then speed would become 30t squared plus 6t, and then acceleration would become 60t plus 6, as an example. Can you see that the t3 ends up becoming a t2, and the t2 ends up becoming a t? Because when you take the derivative, you always have to minus 1 from the exponent. So if this is the formula for the speed, minus 3t squared plus 18t, then you can imagine that the original formula would have to have had a t3 and a t squared. Now, we don't know what these numbers in the front would have been, so I'm going to say a and b. Now, if you had to go and take the first derivative here, that would give you 3a t squared, and we know that this part is the same as this part now, so we can make that equal to minus 3t squared, and then we can simply solve. We can just cancel the t squares out, we can just go solve, and a would have to be minus 1. So that means that this should have originally been a minus 1, so that when you take the first derivative now, you will notice that it'll give you exactly that. And then for this part, if you had to go take the first derivative of that, that would give you 2bt. And we know that that is supposed to be the equivalent of this one. If you just ignore the t's, you get 2b equals to 18. So b would be. So that means that must have been the original distance, because let's just double check. If this was the original distance formula, then if we had to go take the first derivative, we would get minus 3t squared plus 18t. Because you multiply these two together to give you minus 3, and then you subtract 1, and then here we multiply the 9 and the 2, which is 18, and then you get that. So you get that formula over there. So this is the original distance formula that we've now gone and worked out. Okay, but now the problem is, we don't know how long the cyclist has been cycling for. So, one way we could maybe try to figure it out, or what we can try to understand is, we know that when the cyclist started their journey, they would have been at a standstill, because imagine you cycle, you walk out your house, you're not moving, right? So what would your speed be at the start of your cycle? 0. And then when you get to your final destination, wouldn't you stop again, right? So your speed would be 0 again. So what we could maybe do is, and yes, some of you might argue, yeah, but Kevin, what if the person stopped cycling along the way from P to T? What if they stopped and they needed to have a P alongside the road? I agree with you. I don't think they designed this question really nicely, because this person could have stopped multiple times. So I guess to test our theory, let's go see how many times this person stopped their bicycle. So what we can do is we can take the speed formula and we can ask ourselves, at how many places did they stop? So when you stop, what is your speed? Your speed is 0. Okay? Now, if you had to go solve this, you could take out t as a common factor, and you'd be left with, if we had to go solve, we'd end up with t as 0, and so you get t as 0, and then if you had to go solve this one, you'd get t as 6. So that tells us that this cyclist stopped twice. They were stopped at the very beginning when t was 0, so that would have been at the very beginning of their ride, and then they stopped once more, so we can assume that this was at the very end of their ride. They didn't have any p breaks, because if they did, you would have had 3 answers. You would have had something like this. So they only stopped twice, so they stopped once at the beginning and once at the end. So they started the ride at 0, of course, when the time was at 0, and then they ended the ride at 6 hours. So that means that they rode for 6 hours. So they rode for 6 hours when going from P to T. So to work out the distance, we can now come to our distance formula, and we can just say that the time that they rode was for 6 hours. And if we work that out, they rode 108 kilometers. Okay, so quite an interesting question, but there we go. For this question, I will be breaking 11.1, 2, and 3 up onto individual slides, but these are all the questions. A certain number of learners are sitting for examinations in maths, tourism, and geography. So we know that we can just feel the vibes of a Venn diagram coming along, so we might as well go set that up so long. And it doesn't matter which circles you put. It doesn't matter if you label it as this is maths, this is tourism, this is geography, or any other way around. It's fine. It all works out at the end. I'm going to put this as maths, this is tourism, this is geography. First statement. Okay, now we're going to go through all of these statements, and we're going to use that to help us fill in values. But not all of the statements, they might not be useful at first. But let's see. All these learners sit for at least one of these exams. Okay, so there are going to be absolutely no learners on the outside. Okay, there's going to be 0 numbers on the outside. All the numbers are going to be inside these parts of here, because they told us that all of the learners write at least one of these exams. Okay, we've used that statement. Now, this one says the total number of learners who sit for maths is 22. You can't use that right now, because it says that the total for maths is 22. That means that this part, plus this part, plus this part, plus this part, which is everything in maths, must add up to 22. Okay, whoops. It doesn't mean you must put a 22 here, because a 22 here means this is for people who only do maths. But what they're saying is that all of these parts, the whole of the maths, must be 22. Okay, so we haven't used that one yet. The total number of learners in tourism is 16. We can't use that. The total number of geography is 18. We can't use that. We can't even add those 3 numbers together and say, oh, is that the total number of learners? No, it's not, because there's going to be a lot of learners who are doing both. Some learners are going to be doing all 3. So we can't use any of that information. This is good. 5 learners sit for maths and tourism, but not geography. So 5 learners sit for maths and tourism. So maths is over here, tourism is over here. So the intersection is this, but not geography. So they're literally saying that this piece over here is, so we can use that now. So 4 learners do maths and geography, but not tourism. Okay, so maths and geography, so we're going to put a 4 over there. 3 learners do tourism and geography, so we put a 3 over there. And then 6 learners sit for only tourism, so that means we can put a 6 over there. Now here's where it all comes together. If we now come back to this one, they told us that the total for tourism is 16. So tourism is this part, this part, this part, and this part. So now we already have these 3 numbers. That already adds up to 14. So that means that this part must be a 2. Now that is going to help us so much, because now we can work out the maths, because we know that all of the maths must add up to 22. So 5 plus 2 plus 4 is 11. So that means that this must be 11. So that it gives 22. And then for the geography, it must all add up to 18. So we already have 3 plus 2, which is 5, plus 4, which is 9. So you'd need another 9 to make 18. Now we have everything filled in. Calculate the probability that a learner will sit for examinations in at least 2 subjects. Okay, where are the people on this diagram who sit for at least 2 subjects? Well, let me tell you who it's not. It's not these people, because those are the people who do only. So they would only sit for the maths exam. Not these people, because they do only geography. And then it's not these people because they do only. So those students are not going to sit for more than one exam. They are only going to sit for, these 11 learners are only going to sit for maths. These 9 learners are only going to do geography. And these 6 are only going to do tourism. All of the other learners are going to sit for at least 2 exams. For example, these people here, the 4, they are going to sit for a maths and a geography exam. These people here, they're going to sit for a tourism and a geography exam. These people here are going to sit for a maths and a tourism. And then these 2 people are going to sit for all 3. They're going to do a maths exam, geography exam, and a tourism. So they said which learners are going to do at least 2 subjects. That doesn't mean only 2 subjects. It means at least. So those are going to be the learners who do 2 subjects or 3 subjects. So it's going to be the 5, 2, the 4, and the 3. So 5 plus 2 is 7, plus 3 is 10, plus 4 is 14 learners. But now they've asked us for the probability. So probability is always going to be out of the total. So how many learners are there in total? Well, it's the 14 that we just counted, plus the 11, plus the 9, and plus the 6. So this will be the total number of learners all together. And that's going to end up giving us 40 learners. So out of the 40 learners, 14 of them are going to sit for at least 2 exams. And so if you go type that on your calculator, you get 7 out of 20. Now on the memos, or in the exam, you're allowed to say the fraction, 7 out of 20. You're allowed to say the decimal, or you could even say a percentage, 35%. I'm just going to leave it as 7 over 20. Now this one says, determine if the events sitting for an examination in mathematics and sitting for an examination in tourism are independent. Okay, so independent, if 2 events are independent, then the formula is true. This is the formula for independent. And remember that means and. How do you remember that that's and? Well, because we've got the word n. So how can we go test to see if the formula is true? What you're going to go do is you're going to go calculate this part. Instead of saying A and B, I'm going to say and T, because we're using mathematics and tourism. We're going to go work out that part. And then the next thing we're going to go calculate is we're going to go calculate this part. So that would be the P of maths multiplied by the P of. So we're going to go calculate those 2 parts individually or separately. And then if they are equal, then we can say that they are independent. And if they're not equal, well, then we'll say no, they're not independent. So where is the probability of maths and tourism? So where are the people who do maths and tourism? It doesn't say maths and tourism and not geography. It just says maths and tourism. So maths and tourism is those people there, okay? It doesn't say that they can't do geography. If you had to walk into a room and say, can everyone who does maths and tourism, or maths and tourism, please stand up? Then all 7 of those people are going to stand up, even if 2 of them also do geography. It doesn't matter. Okay, so that's going to be 7 people out of a total of 40. Now we're going to go do this part. So this is maths. So where are all the people who do maths? And they're talking about maths in total. So that's going to be 22 people. So that's going to be 22 out of 40. Multiply. Now where are all the people who do tourism? Well, tourism is everything in this. So that's going to be 5 plus 6 is 11, plus 5 is 16. I think that's what we said earlier, hey? 16, yeah. So 16 out of 40. Okay, so if we had to go calculate this, we get 11 out of 50. So can you see that these 2 are not the same? So the P of M and T is not same as, so that means determine if they are independent. So we'll say no, independent. Here are all the questions we're going to do for this one. It's 12.1, 2, and 3, but I'll be breaking them up onto individual slides. A company generates a 4-character code using the 26 letters of the alphabet and the 10 digits from 0 to 9. Okay, so it's got letter, digit, digit. Determine how many codes can be formed if the letters and digits may be repeated. Okay, very, very easy. For the first one, how many letters can we choose from? 26. For the digits, how many can we choose from? 10. Now for the letter for the next one, how many can we choose? 26 again. Why? Because they said repetition, letters and digits may be repeated. So even if you used an A over here, you're allowed to use an A again. So if you wanted to put a 25 here, that would only be if repetition was not allowed. Okay, and then for this next digit, it's still going to be a 10 because repetition is allowed. Now you're just going to go multiply all of that together and you get 67,600. Determine how many different codes can be formed if these letters may not be used. Okay, the code may not start with a W or a Z, letters or digits may not be repeated, and the code must end with a odd. Okay, so we definitely can't use 1, 2, 3, 4, 5, 6 letters. Okay, so that means we only have 20 letters that can be used because these 6 are not allowed to be used, and the code is not allowed to start with a W or a Z. Okay, so then how many options do we have for this first one? Well, out of the 26 letters of the alphabet, you're not allowed to use those. So we only have 20 options available, but the code is also not allowed to start with a W or a Z. So we actually only have 18 letters available for that first one. Now, for the digits, I'm going to ignore the first digit and I'm going to go all the way to this last digit. They tell us that the code must end with an odd number. So then we're going to put, what odd numbers could we put there? So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that could be a 1, a 3, a 5. That's 1, 2, 3, 5. So we've got 5 options we could use over there. Let's pretend we used a 1. How many digits are we available, or do we have available over here? For now, we've only got 1. You could use any of them actually, because this digit can be anything. You just can't use the odd number, which we said that we pretended that we used a 1. So you could use any of the other 9 available digits. So you put a 9 over there. And some of you might be saying, but Kevin, shouldn't we look at this one first and then this one would only come afterwards? No. So the way it works is you always want to go to the biggest restriction first. So the biggest restriction we had with the digits was this one. So we start with that one. Okay. And then what would we have over here? Well, this would now be 17. And then what about this one? Okay. So what we need to understand is that these letters are not allowed to be used. So we only have 20 letters available. For the beginning one, we were not allowed to use a W or a Z. So we only had 18 options available. But now for this one over here, we are allowed to use a W or a Z. So there's actually going to be not 20 options available anymore because we've already used one of the letters over here. So if you just give this some thought, but this is going to be 19 available options. Let me explain. So we can use the letters A, B, C, E, G, H, J, K, L, M, N, O, P, Q. No, we're not allowed to use Q, E, U, V we're not allowed to use, and then W, X, Y, and Z. Okay, so those are the letters we're allowed to use, but we're just not allowed to use the W or the Z for this first option. So that's why we crossed those out for the first option, and then we were allowed to choose from the remaining 18 letters. So let's say we chose an A. So let's say the A is now chosen. The W and the Z are available again for this one over here. So out of these 20 letters, only the A has been used up, and so we still have 19 options available. And so now we can just go multiply all of this together, and that's going to give us 15,390. This one now says the company wishes to increase the number of 4-character codes formed in question 12.2 by allowing these 6 letters to be used. Remember in the previous one, those letters were not allowed to be used. Well, now they are allowed to be used. So calculate the percentage increase in the number of different codes that can now be formed. Okay, so we will assume that all of the other restrictions are still in place. So here are the restrictions that we still had from the previous question. The only thing that's changed is that we are now allowed to use these letters. Okay, so we're still going to have 4 characters, and now we're allowed to use all the letters in the alphabet, which is now 26 again, but we're still not allowed to start with a W or a Z. So for the first option, we're going to have 24 options available. Then for this last digit, that's still going to be exactly what we said the last time, which we said was a 5. And then for this one over here, we're still going to keep that as a 9. And now for this one over here, we just got to be a little bit more careful. So we have all 26 letters available to us. We were not allowed to use a W or a Z for the first position, so we just said 24. So you can imagine if you've got all 26 letters of the alphabet available, let's pretend that we used the A over here. Then how many letters do we now have available left over? Well, it would be 25, because we've only used one letter in this first one, and the W and the Z are now available again for this part. And so this is the total number of codes. Work this out. So 27,000. Whereas in the previous question, it was 15,390. So previously was 15,390. So to work out the percentage increase, you're going to say 27,000 minus the 15,390, and you always divide it by the original answer, which was that one, and then you multiply that by 100, get the percentage, and that's going to be, and then times 100, and that's going to be 75.44%. 75.44%.